Okay. Welcome back from lunch. Hope everyone isn't too tired after a big lunch. I am. So before we have a discussion and open it up for questions, I have a brief exercise, and I passed around these sheets. If anyone did not get one, I have more. Let me know. But it's a simple exercise where we give you a river cross-section and we give you the widths, and we want you in the first part to calculate where you would collect samples using the EWI method. And then on the back, we give you information from our EDI program that tells us the stations for the EDI sampling. And we just want you to mark roughly on the graphic where those stations might be. So read through it. It is in English if you need help. I'm sure there's plenty of people to help answer questions about some of the, if you're not sure what something means. And just work through that, and we'll go over it as a group in a few minutes.
I'm going to give the rubber prize.
Oh, we should. How many people have finished the EWI stations? EWI finished? How many have finished the EDI? Okay, keep working for a few more. Yeah. Okay, let's go over this exercise. Okay, so the first example is if you were going to sample this site using the EWI method. So we had a total width of 140 meters. We decided to divide that up into 10 sections of equal width. So then what is going to be my width per section? 14 meters, okay? So where's the location of my first sampling section? 7. Yeah, so it's in the middle of each section. So what's the location of my second vertical? 21. Okay. What is the stationing or location of my last vertical? 133 meters. Good. Yeah. Where would I go to determine my transit rate? Which station number?
You have the 2 meters of, so we'll be at 9.
Which station? Or where are the stationing?
The offsets will be 2.
Right.
So first station will be at 9, isn't it?
9 meters. Yeah, well, 9 meters. There's really 2 scales on here. It's 7 meters from the edge of water. 7 meters from the left edge of water. Okay, so what station number would you want to pick your transit rate? 7, probably 7 or 8. Would you probably get similar answers there? 7 or 8, okay. So I'm going to show you an example of setting your transit rate for EWI in a minute to help illustrate picking a proper transit rate that's going to work for all sections. But for now, let's go to the EDI section. So based on EDI, this was simply a matter of just marking on the graph where you might collect. So I'm going to put this up. And does somebody want to volunteer to use the laser pointer and mark where they would put their verticals? Volunteer? Volunteer, all right. Good.
Where should I press?
The underneath this one.
Oh, okay.
See if it works. Is it on? Oh, there we go. Maybe? There.
Oh, okay. So my first one.
You might have to do it here.
Okay. Minha primeira seria por aqui.
Uh-huh.
Pode deixar, obrigada. A segunda, the second one around here.
Mm-hmm.
A terceira,
Mm-hmm.
about here. Quarta, here.
Yeah.
E a quinta, aqui.
Good. Good. Thank you. Any questions on that? Straightforward, but yep. Okay.
Então, para o primeiro exemplo, eu coloquei 2 resultados. Eu gostaria de discutir sobre se eu estou viajando. Eu coloquei como primeira resposta essa primeira vertical a 7 metros, e a segunda 21, terceira 35, assim como o gabarito. E coloquei como possível segundo resultado a divisão da seção total pelo critério de 10 mais 1, que é o número de verticais que eu quero, e me daria um espaçamento absoluto constante de 12,72 metros, 12,7 metros. Aí, ou seja, a pergunta é, o igual incremento de descarga, de largura, perdão, além de a distância entre as verticais ter que ser constante, também é necessário, ou poderia, essa distância também ser igual da primeira vertical para a margem e da última vertical para a margem oposta? Porque dessa maneira que eu fiz de 12,7 em 12,7 metros, seriam todos os espaçamentos iguais, inclusive para as margens, entendeu? Não, manter o mesmo espaçamento do início ao fim, inclusive da primeira e da última vertical para as margens, entendeu? Qual seria o mais interessante? Qual seria o mais representativo?
So is this a difference in methodologies with the N+1? I mean, I think it's simply, I mean, so you're saying you are collecting 11 samples? No.
Só um artifício de cálculo.
Hang on.
É só um artifício de cálculo. Eu dividindo por 11, eu terei 10 verticais dentro da minha seção, e nenhuma vai bater na margem, entendeu?
They should, with 10 verticals.
Mas aí ele está mudando o método, que em vez de ser meia seção, é seção média. Ah, pegadinha que você queria.
So with 10 verticals and equal spacing, you're half the distance, half the width off of each bank, but each sampling location is equal to 14 meters apart. So what you're saying is you're starting, the spacing is the width of each section. So you want equal width of each section. So, and you get that with 10 verticals and 14 meter width. Is that, I'm not getting, I think I'm still not understanding the,
A primeira não seria metade, seria já o espaçamento.
Não, porque o que me interessa é a parte molhada do...
Deixa eu tentar explicar. Deixa eu tentar explicar, que talvez eu que seja o culpado aí, né? Já que eu passo assim nos cursos, mas tem explicação, né? O que a Molly está fazendo é realmente dividir pela quantidade de verticais, da forma que a gente viu aqui, está perfeito, isso mesmo. Como é que a gente faz aqui no Brasil? Inclusive, a gente passa nos nossos cursos, né? Deixa eu tentar explicar aqui bem rapidinho. Talvez o que eles façam lá seja até o mais adequado, mas no nosso caso aqui, eu acredito que não faria diferença, né, para o método. A gente faz o seguinte, pega 140, então seria o igual incremento de largura, a gente pegaria o 140, dividiria pelo número de verticais mais 1, então ficaria 140 por 10 mais 1, isso vai dar aproximadamente os 13 metros, né? Para não ficar... Acho que dá 12,7, não é isso? Você pegou. Então, o nosso seria o seguinte, não seria nas mesmas verticais, da margem para aqui, teria 13 metros, aí para a outra mais 13 metros, aí a última ia estar aproximadamente 13 metros da margem. E a gente faz na própria vertical. Aí, no nosso caso aqui, qual é a hipótese, né? Só para discutir, inclusive, com o pessoal do SGS. Vamos pegar, se fosse, no caso dele, só com 3. Né? Ó, com 3, ele dividiria, vamos supor que aqui fosse 30, né? Então, aqui 30 metros, a diferença que vai ficar mais fácil. Eles dividem direto por 3, né? Então, daria 10. Então, eu teria aqui, na realidade, não seria a nossa vertical, está 10 e 10, né? Na primeira ele coloca aqui, seria em 5, correto? Então, aqui seria a vertical deles, vertical 1, mais 10 metros, aqui seria 2, mais 10 metros, aqui seria 3, né? Então, está certinho deles. O incremento de largura deles é isso aqui, ó. Não é? Que está exatamente 10 metros cada um desses. Só que, assim, isso é no meu ponto de vista para... Está certíssimo, acho que é assim mesmo do método. Só que, o que é que o método igual a incremento de largura e o método igual a incremento de descarga faz? É simplesmente definir as verticais de amostragem, nada mais que isso. E isso aqui nós estamos fazendo uma hipótese, né? Qual é a hipótese aqui? Ó? A hipótese é que, porque eu não estou interessado na concentração da vertical, eu estou assumindo que a concentração dessa área toda é igual à da vertical. E a gente sabe que não é uma aproximação. No nosso caso aqui é a mesma coisa, só que nessa situação, para o nosso caso concreto aqui, só botar só de outra cor, ficaria 30 por 3 mais 1, daria 7,5, não é isso? Ó? Então, a gente, em vez de... Deixa eu colocar aqui. Aqui seria 5, aqui seria 15 e aqui 25, correto? No caso do SGS. No caso da gente, isso seria aqui 7,5, que isso aqui já vai ser uma diferença. Como o incremento, a outra seria mais 7,5, daria 15, que vai aqui, né? E essa aqui mais 22,5 seria aqui, ó. Então, no nosso caso, o que a gente está considerando? Ó? Que essa área aqui, ó, na realidade, o ponto médio, né? Que seria isso aqui, ó. E esse aqui. É aqui, né? Então, a gente está considerando que dessa área toda aqui, ó, a concentração média que está sendo medida aqui. Que também a gente sabe que não é, que teria que aumentar o número de verticais. Né? Eu acredito que não tem problema, a gente faz desse jeito, porque, de qualquer forma, no nosso caso aqui, eu estou pegando 3 verticais, elas estão... Porque aqui é um exemplo só com 3. Normalmente a gente não faz com 3, a gente faz no mínimo 10, né? Então, a única diferença vai ser mais na margem, porque essa da margem, ela está com incremento maior das duas margens. A do meio está igual, entendeu? A priori, do meu ponto de vista, não tem problema, apesar de que, na risca, olhando no método, o que eles utilizam lá seria mais... não exato, mas aderente ao que está no método. Mas é por causa dessa hipótese aqui, né, pessoal? No meu ponto de vista, é porque a gente está fazendo o seguinte, a gente está fazendo a amostragem numa vertical, só que eu não quero da vertical. Eu quero na seção toda. E eu estou assumindo que a concentração nessa área toda é igual da vertical, que eu sei que não é. Isso vai ser verdade quando eu começar a aumentar muito o número de verticais. Entendeu? É uma hipótese. O que interessa é que ele tenha iguais espaçamento entre as suas verticais de amostragem. Apesar que eu acho que a forma que eles fazem lá seria mais aderente ao método.
Então, você explicou perfeitamente aí. Agora, o que me leva a refletir é o seguinte, que a gente tem que considerar, ao meu ver, qual é o desenho da minha margem. Dependendo do tipo de margem que eu vou ter, uma margem reta, vamos supor, retilínea, encaixado. Mas se ela for assim, dessa maneira, eu esqueci, me perdoa agora o termo técnico que se dá, que ela vai inclinando, assim, como se fosse tendendo ao semicírculo, pela primeira vertical ser muito próxima da margem, eu acredito ainda que esse segundo resultado que eu coloquei, o nosso método que a gente usa aqui no Brasil, seria mais representativo, porque extrapolaria menos, por causa da característica da margem, inclinação. Você está entendendo? Porque uma vertical, considera só, ela considerou, no método dele, 7 metros da primeira margem, da margem inicial. Eu considerei...
Não,
de acordo...
foi 5. O dele é 5. Nossa, que é 7.
Não, perdão, estou falando do exemplo anterior, do exemplo aqui do
bom.
exercício. E o nosso 12,7, ou seja, seria um espaçamento constante na sessão inteira. Ao meu ver, desculpa a ignorância, eu ainda acho que seria mais representativo, porque considerando o desenho da margem. Você está entendendo? Porque extrapolaria menos. Tipo assim, ó, uma vertical, você concorda que na vertical 7 ali, a realidade que ela tem de células assim mensuráveis ali de vazão, feixes de vazão, do lado direito, é super diferente do que ela tem do lado esquerdo, da vertical, sabe? Você está entendendo o que eu estou querendo dizer? Diferentemente da posição 12,7. Se fosse do 12,7 metros,
Não, entendi.
seria bem mais representativo.
Acho que a discussão é válida. Essa é uma diferença que a gente faz aqui. Não sei se no passado é feito dessa maneira. Pelo menos da forma que a gente tem dado os cursos nos últimos 15 anos, era essa maneira aqui. Mas eu acredito que isso não vai ter nenhum impacto no resultado. A gente poderia fazer aí, sei lá, não tem esse controle aqui, poderia fazer N medições, até porque, ó, só para a gente também não estender muito a discussão, que eu acho que isso aqui não é tão relevante, apesar de ser diferente, só para vocês terem uma ideia, já justificando, depois ver a opinião do pessoal da SGS, isso aqui não vai impactar em nada, o que impactaria é se você realmente está mudando as distâncias internamente, entre uma vertical e outra. Mas não é o caso da gente. Reparem, lembra lá no slide que eu coloquei, que é da publicação do SGS, nos métodos igual incremento de largura e no método igual incremento de descarga, eles conduzem a resultado diferente ou resultados semelhantes? E são verticais diferentes. Entendeu? É só um método para você não chegar na sessão e falar o seguinte, como é que a gente vai amostrar aqui? Não, faz em qualquer vertical. Não é, porque isso não é reproduzível. Aí tem um método. Um método é o seguinte, ó, um é baseado em iguais incrementos de largura e o outro é baseado em iguais incrementos de descarga. Desde que atenda a isso, vai conduzir o mesmo resultado, que é o caso daqui. Eu acho que isso aqui não vai ter diferença, não vai ter impacto nenhum no resultado. É só para a gente não ficar, às vezes, se é 5 metros para lá ou para cá, etc. Entendeu? Eu acho que não vai ter diferença. Não sei se o pessoal do SGS... Mas, assim, já... para a gente não ficar mantendo a posição, até acho que a forma que eles fazem é até mais coerente e aderente com as hipóteses do método. Apesar de que, da forma que a gente faz aqui, também não vai ter diferença nenhuma no meu ponto de vista.
Yeah, I agree. I think when you get to the point where you are collecting data from that many verticals, both methods are following a systematic way of representing the variability, and you're going to come to a similar answer. You may do a side-by-side comparison at one river at one time, and you might get slightly different results. You might come back to that same river again and do a comparison, get the same result. There might be little variations, but I think in the end, you're going to get a very similar answer with those two approaches. So it's not that one is better than the other. I think that both of them are systematic ways of representing the variability, and both would give you a similar answer. That's my opinion. Yeah. Tim, Mike, do you have any thoughts on it that you want to share?
Just a couple. I believe what Walston's saying is true. It's not going to make that much of a difference in most situations, but and also with Molly. I mean, I think that is because a lot of times on the edges you've got the shallower, slower moving water, and so you're not weighting that. You're not skipping out and discounting that. So with the difference of those two sections, like Tim had told me just a few minutes ago, we're kind of in the midpoints. We're measuring the midpoints of those sections. And so that's where that's developed from, is that right? Where we're actually going through the midpoints like a discharge measurement is configured. Right.
Okay. Okay. Any questions? Okay, so let me show you something very quickly. Okay, so this is an example showing you, it's illustrating how to pick a transit rate that's appropriate. Specifically, I want to show this for the EWI because you're selecting one section, one vertical for deciding your transit rate. And how do you make that determination once you pick that vertical? And so I want to show you this to illustrate. This came from Mike. I really like this example. This is a station that it's 2,000 feet across, and they're using a D96 bag sampler. Okay, these were the stations that we calculated using the USGS EWI method. At each of those sections, these are the depths in feet. And normally, again, with EWI, you don't always have a sense of the velocity in each. But we, for this example, we estimated the velocity at each vertical to give you a sense of how we go about picking the transit rate. So the deepest, fastest section is this one right at 1,100 feet. Okay, it's 36 feet deep, 10 feet per second, and this is where we want to pick our transit rate. So how do we do that? So the nozzle we're using for this scenario is a 3/16 inch. So the first thing that you could do is do some tests by lowering the sampler and see how long it takes to fill that bag. And based on this chart, to go down and back with a 3/16 nozzle with a D96, it's going to take 55 seconds to fill it. So you could do some tests. You could lower the sampler, pull it back up, and time how long it takes to get the maximum volume. And that could give you a good indication of what your velocity was in that section. So that's one way you could do it. Or if you had a measurement, a discharge measurement, and you had velocities, you could take that velocity directly. So it took, at this section, 55 seconds to fill up my 3-liter bag at this deep, fast section. So I have a pretty good confidence that my velocity is around 10 feet per second based on that time. Now I am going to look up my transit rates. So based on the table, this is the transit rate table that I showed you before. This is a table specifically for the combination of a D96 sampler and a 3/16 inch nozzle. So my depth at that section was 36 feet. So I'm kind of between these two entries, between 35 and 40. But since I'm pretty close to 35 for illustration, let's just pick that row. And then I'm going to cross over to where that matches the estimated velocity in that section, which was 10 feet per second. So the first number is the slowest transit rate I could go, and the second number is the fastest transit rate. So I could raise and lower that sampler between 1.3 feet per second and 4 feet per second and be within the acceptable limits for that section. That 4 feet per second is determined by that 0.4 times the velocity in that vertical. That's that upper limit, the fastest you can go. And the 1.3 is determined by if you go slower than that, you're going to overfill, essentially. So let's fill that in, okay? So this is my range of acceptable transit rates for that vertical. Let's say we had velocity information for all of those sections, and we were able to determine what the appropriate transit rate would be for each section. So looking at what my range is in my deepest, fastest, compared to what my ranges are in all the other sections, what would be probably a good transit rate within this range that would satisfy the requirements in all of the others? Yeah, probably on the lower end of the range for this vertical. So 1.5 to 2 feet per second, I would be completely within the limits of all the other sections. So you don't always have the luxury of velocity information at all of the verticals for EWI. So when you set your transit rate at the deepest, fastest, try to err on the side of slower. You want to get as much volume as possible at that vertical without overfilling. And if you're on that end of the range, you should be okay with the rest of your verticals. Okay? Does that make sense? Okay. Okay, so we've just got a few more minutes probably. Are there questions on sampling methods before we start talking about large samplers and large river considerations? Okay, Mike. You ready? You want me to?
Explained it better than I did.
I think that was perfect. I'm glad you gave that to me because I think that illustrated it way.
It's a little bit more simplistic.
Oh, yeah.
This is off, right?
It is on. The green lights.
Okay, so I guess we should get started. Guess we should get started. How many here have collected samples from a boat that's not on a tether, on a tag line, on a rope, that's a controlled boat that's free floating? Almost everybody. Everybody here? Okay, okay. Good. Then we can go on to the next presentation. So what I'm going to show you here is how we approach these samples in our larger rivers, which I know is much different than the way that you approach it here because of distance and area covered, the campaigns that you run here for many weeks, out collecting many samples. For the most part, we can collect a sample for the majority of our larger river sites and return back to the office, but there are occasions where we have field trips and there are 4 or 5 sites throughout the week. So a lot of our boats are trailerable, most of them are, and so I just wanted to show some of this, and this is the way we approach sampling our large rivers. So I was asked one day, what's a large river? Well, there's no real definition for a large river. But as you can imagine, as you've experienced, it's a river that, you know, it's not wadeable and it has to be approached in a different way. There's no bridge. The bridges are too high to sample off of. The span of the river, the width is just too large. There's no safe crossing or accessibility. The velocity sometimes can be much higher, which requires using larger samplers that you can't use in smaller boats. And we also have increased depths that are included. And because of the increased depth, we're having to use these collapsible bag samplers or flexible bags. So for the most part, sampling larger rivers with boats cannot be done like this photo here on the right. With the freeboard here is just not enough. This boat does not have the capacity to carry or deploy a large sampler, like the D99, your MS8, and so forth, because of the weight required. And so these type of boats we use frequently on our rivers in the U.S. These are made by Sea Ark. We have several different types. Some of them are different. We usually have twin outboard engines to help us control the boat in faster flood waters where the water velocity could be 3 meters per second or higher. And there's a larger freeboard. So in talking about these boats, we have had some built specifically for doing this type of work. This boat here is a new boat that we had built by a manufacturer in Arkansas. And where we're going to is developing these boats or using or trying to have a set plan that works well for everything. So this rear cabin facing idea where the crew is working in front of the captain and he can view everything on the boat that's going on and he's not moving around seems to be the safer way to go. And it also keeps the ballast off the boat, and we're sampling from the bow of the boat. Here is the rig, the boom, the davit that's being built at this shop. And so these are some average costs. It depends on the things that you want to put in. This boat has a live well that was built here that deploys the ADCP 600 through the floor of the boat, and they close it up, so there's no deploying the Doppler off of the side, the front, the back. So there's some different options there. This is a boat in Mississippi that we took and had remodeled. It was going to be surplus, and so we took it to a boat manufacturer that could refurbish a boat in Vicksburg, and we basically stripped it down. It already had this style boom on the back. It came from the manufacturer Monarch in Arkansas, built these type boats back in the 70s. They were very popular in that era. This is the boom that was already fitted into the back. We did some modifications to it. We had it painted and so forth. And this is that was the estimated cost that we spent on that vessel. Now, to buy a new boat with the electronics and all that we put in this boat would be considerably higher, but we spent a good bit of time. It took about 3 years to do this boat. So the anatomy of a sampling rig, they are all types. It's fair to say that sampling booms or rigs are built specifically for the boat that they're used from. This is a setup in Baton Rouge on the lower Mississippi. This is a pivot point. Here's an auto reel. This is the reel. This is looking toward the rear of the boat. This is just pretty much a schematic, a CAD drawing of the same style. The auto reel has a pulley system that drives the reel, and it has communication cables and handhelds that are run so you can operate the unit. But basically, these are mounted where there is substantial material, steel, aluminum, that can support this weight with gussets that are out over the boom, supporting the base. Here's another gusset. This is actually it's a cover for the drive belts to keep fingers out of those belts while they're moving. This is the one we have in Mississippi. It was kind of a hybrid, but as you can see, this is the entire drive unit and the E-reel, the USGS E-reel. It was designed in 1953 and is still used today. I'll talk more about the reel and these other particular parts. So sampling boom placement. We've learned a lot about this over the last several years in the USGS, some of it of which came about suddenly, and so I will share some of that with you tomorrow in our safety talk. This is the same boat from Louisiana. The boom was moved a couple of different times, but it was found to be the center of gravity in the back of the boat that keeps the boat balanced while the sampler's being operated. This boat uses the D99, the D96. It was using a shipwreck type bed material sampler, but has now changed over to the BM54. This is our T.E. Anderson boat. This is in Vicksburg, and it's using the 99. This is the 99 sampler off the back. This is a shipwreck type bed material sampler. During our large river course, these are some Corps of Engineer folks that are with us. The one thing that I want to state here is that we are just not recommending taking any type of bed material samples off of these size boats. These are 26 to 28 feet. I'm sorry, I don't have the conversion for meters. Because they're capable of doing this, but in sampling bed material off of the rear of a boat, if that sampler were to become connected or hung on a hazard on the bottom, a tree trunk, a sunken boat, some sort of concrete where you could not get that sampler back up, what happens is you become anchored off of the stern. And you don't anchor boats off of the stern, you anchor off the bow. And so any type of bed material sampling, if at all possible, should be done off of the front of the boat. And I'll show you another setup. So these are bow-mounted boats. This is an old boat from Arkansas. This is a boat in New Hampshire that they actually came down to the large river class, and they took pictures of our boom off of this boat here and actually modified it and made it fit to this boat into a fiberglass. And so they've got supports here at pivot point here. They can operate the sampler, swing it out over the front, bring it back, lock it in place, and unload the sampler and sample off the front of this style of boat. This is the boat that I was showing you that was built in the shop with the side boom. This is a new design boat also. It has a, from Baton Rouge. You notice the freeboard here that this boat has. It's very safe to operate these samplers with. It doesn't tilt the boat, it's balanced. And so you can see these folks here. This is during our large river class. We're demoing here. This is a P6-200. And so it's got gussets, it's got the motor reel here. All of the wiring is built into the boat. It's got a pulley system, drops off to the side. So large river samplers. We've seen some of these that Tim and Molly have shown in their presentation. You've heard from them, you've heard of them. This is a frame sampler that the USGS used before we had the actual molded in, nice looking enclosed collapsible bag samplers like the D96 or the D99. Same type of setup with your MS8 sample. A weight, hanger bar, frame. This just does not have the shield. And so it's an open frame. This sampler was used for many, many years until the D96 and the D99 came out and actually produced a lot of, the efficiencies were very good. The problem is, as I was stating before, when the USGS began sampling and getting more into trace metal sampling, these lead weights and all of this metal became an issue because of the parts per billion and the trace metals looking at. So we had to go a step further to eliminate that. We didn't have a sampler that would do all of the above. So this is a current meter, the way that this was done in the past. As it was lowered down, the current meter was active, and you could hear the clicks through the line, get the velocity where the sampler is, and then you would be able to measure the velocity as you're going up and down. There was no power reel here. It was power, but it's one speed only. So that was a holdback. This actually, I think, is a hydraulic type reel where they were able to change that speed of that motor and that reel to some extent. And some of those still exist. So this is the D96 sampler. These are the specs on it. I have a couple of things I want to pass around while we're doing this. What type of bags do you use here for your sampler? Are they plastic, the Teflon? Plastic? So I've got some examples of Teflon bags that we use for water quality, but for sediment only, the plastic, fine. But this is a dual purpose bag. I'll pass this around. You can feel the difference in that bag. And here is the cheaper. Now the only difference between these two, these are cents, 20 cents, 10 cents a piece. These are $20 a piece. So So I'll just point out on this photo here where this boom is set up on the back. If you're doing this type of work, regardless of how you build these booms, make sure they're supported, and you can reach the sampler to unload the bottles or the bags, and that the boat is balanced. And so that's a major thing that you want to look at. These are the nozzles, and Tim discussed this earlier. This is the maximum capacity of this sampler is 3 liters, although if you collect 3 liters, I think you've collected too much. It's like my son's baseball coach says, be here at 8 o'clock. Well, if you're there at 8 o'clock, you're late. You need to be there at 10 till 8. So if you collect 3 liters, you've reached that maximum limit, and you probably have gone over. You just don't know it, because it's only going to hold. I've never actually been able to collect 3 liters or more, so it can be done. This is the D99. You've seen pictures of it before. It has a different opening, a different setup here. I can pass. This is the nozzle and setup, a Velcro setup for this bag. This is a 6-liter bag. This is a Teflon bag, similar to the size that the MS-8 uses. I was discussing with Tim earlier that, and I'm not sure how the bag attaches to your MS-8, but it matters on how these bags are attached to these nozzles, the nozzle holders. And I am not the best with my fingers, but I can get it done. But what you want to do is you want to gather it from all sides so that the opening to this, the back of the nozzle holder, is not restricted with the bag. Does that make sense? And so if you take and you push it to one corner and then try to wrap it around the holder, and this may not be the case sometimes, but what you're doing is when that water starts to flow into that nozzle, especially at lower velocities, you're going to impede that opening. So it takes it and it turns the bag up, so it needs to be open and free so the water can just flow in. Now, I was hoping that would stay on, but I'm going to pass this around. You guys can play with this and look at it and practice putting that on. So transit rate tables, I'm just going to spend a few seconds on this. These are the tables that come with these samplers. And they're the maximum filling times with this stream velocity with these nozzles. And so what you have to do is you look at your stream velocity and the nozzle that you're using and pick out the filling time that they've calculated for you. Then you take your depth, as Walson was saying yesterday, times 2. So if you're 60 feet, you've got 120 feet. Feet per second, you take the distance divided by the seconds, it gives you your rate. Does that make sense to everyone? So, now this table here is what our National Field Manual people, folks and groups have already hand computed. They've done the math for you. So they give you the range of the efficiency triangle that you were showing the other day. And so these are just all of those different transit rates, and it gives you a little bit more flexibility on the amount of water that you're collecting. You may want to limit that, and so you may not want to collect 2,800 milliliters. You may only want to collect 1,000, maybe. And so this will allow you to adjust those rates. Because we composite some of our samples, and our compositing containers for our water quality, our churns, are limited by the volume, so we have to be careful on how far we go up the ladder with our rates. This is the point sampler. Not going to spend a lot of time on this, and as Tim showed this morning, the ones that this replaced, the P61, some of the earlier P63 samplers were much more complex in the head and the way that the solenoid works and opens and closes. This sampler has a solenoid, and it's powered through the cable that holds it with 12 volts. and it's powered so that it's closed. You mash the switch, you cut the voltage off, the switch opens up and the valve opens. You flip the switch, you put the voltage back on it, it closes that solenoid. That's the theory. This has to be tested before you use it, so you need to lower it down. The magical depth is 15 feet, and you hold it for over, I think, a minute. I'm not sure of the exact time. And so bring it back up without opening the valve, and you open it up. If your bottle's empty, everything's working. It's not leaking. Put the bottle back in there, close it back up, send it back down, and then it's a matter of seconds that you have to keep that valve open to collect that point sample, and then you bring it back up. There are people that think that you can take this sampler and use it as a depth integrating sampler, but the designers say no. It was not designed for depth integrating. Don't hold it open and send it down 10 feet and bring it back up. Wayne O'Neill, who is retired, that designed these samplers and actually still makes a good many of these, makes that statement with his foot down. Do not use a point sampler as a depth integrating sampler. So supporting sampling equipment, this is the e-reel. It can be hand operated. I have 2 question marks up there because I highly do not recommend doing that. And I'll tell you in a minute why they supply this with a handle. This reel was designed to operate the heavier samplers or heavier weights for flow measurements with like price current meters, those type of things. It has, it's got a depth dial, the connector. This is an all thread. This pulley here or sheave, it keeps the cable reeled onto the drum at a certain point. And of course, you've got a handle here that operates a brake. This was designed to make measurements off of a bridge or a crane, and it would free fall the weight, and then you could apply the brake and it would slow it down where you could stop it. You may be familiar with this. So the maximum cable lengths that this reel will hold is 165 feet or a little over 50 meters of 0.125 inch cable, 0.3 centimeter cable, and around 200 of the 0.1 cable. For the most part, we use the 0.125 cable with these heavier samples. It's rated to hold somewhere around 1,800 pounds. I think the other cable is around 6 to 7, maybe 800 pounds. But we always want to double the safety factor, or triple it. So this is the power drive system that was developed years ago. This was to our sampling program like sliced bread, because it took all of the work, the guesswork that we were trying to do in controlling the rates down to nothing. It is expensive. It's not quite as expensive as the D99, but it's made up of several parts. It has a bracket here that can mount to a position boom that you have to design so that it will have a bracket for this. It controls the speed from somewhere around 0.2 to upwards of 3.5 to 3.8 feet per second. Although when this system was testing the reels and the samplers, they said that the brass off of the pulley was flying at close to 4 foot a second. So that's at the maximum that and this has been one holdback, but our hydrologic instrumentation facility has revamped this system and made it better over the last couple of years. And so now it will operate some of our heavier samplers at a higher rate. So they beefed it up a little bit from the original design. So this is the handheld that goes to, it plugs into this unit here, which is the processor box that has a couple of settings on it. It has it has the power that you're using and how much power you have left. When you're operating these heavier samplers in these open waters, you want to be sure that you don't run out of power and your sampler's down 50 meters and you have to go back to the hand crank and crank that sampler up by hand. I can tell you that's not fun. This is the dial that comes on the side of the reel, and this is the only true way to know exactly at what depth the sampler is going to. This does have a depth indicator digital on there, but it's run by these pulley belt system. And the belts can slip, and so over a couple of transects, it starts to get off, and before you know it, you don't think you're going to hit the bottom, and the sampler hits the bottom. So the only way to really truly know where you're going is to use this type of dial system. So power. So let's say we're using the D99, and it's 280 some odd pound sampler. That auto reel system will work off of 12 volts or 24 volt system, DC. But in a 12 volt system and a heavier sampler like that, you're only going to be able to make maybe 5 to 8, maybe a few more than that, transects up and down, and you're going to notice your power is going down, down, down. Highly recommend only using a 24 volt system to operate those samplers like the 96. It'll just be less trouble you have to worry about. We used to change these batteries out every couple of weeks, but it's very labor intensive. We have found these 24 volt chargers that will hook to a generator that's supplying 110 volts, and we can wire this directly to these batteries as a bank, and our system has 24 volts continuous power. And so it really alleviates having to unload the batteries, spend that kind of time. We can spend our time on other things. So this is a list of sampling things that are involved in these large river type samples. I did this for a cooperator that wanted to know actually what the cost was if they were going to get involved in sampling depth integrated samplers themselves. So here are the samplers. The 96 is somewhere around $6,300. Now these prices may have changed since I made this. The D99 somewhere around 10, and I've got these converted over to the conversion that was when I made this for this class. Extra trays, the 3-liter sampler bags, they're $15. The 99 sampler bags, and so it goes on the little straps, and as you can tell, some of the nozzles, they're fairly expensive. The nozzle holder that you saw that I was passing around, it just keeps going down. The variable drive, so here it is, it's $8,500 or 34,000 reels. The inverter to produce the 24 volt power, continuous power, it's about 700 reels, $190. Gallon containers to pour your samplers in, the milk crates, and so it all adds up. Now this price here does include 2 samplers. You wouldn't have to have 2, but I just included all of that. So let's put it all together. We've seen the boats and how they're kind of laid out, how we do this in the U.S., and we've seen some of the positions of the rigs and the sampling booms that we seem to find that works best for us. And they're all a little different, but they use basically the same equipment. And the methods that Tim and Molly have been going over and we've seen all week. So the equal width increment. We saw that demoed here earlier. It's a little difficult to do this on a 3,400 foot section. Where do you find the 340 foot distance mark? You could do it with a rangefinder. You could, there are methods. Transits, bank markers, that type of thing. Years ago in the 80s when I was sampling the site at Vicksburg, the boat contractor that we used to ride on their boat, he used to use some of these trusses to line up on. And so that was one method. That was before actually we had the ADCP technology. The point samplers, of course, they're totally different, but they can be marked either by discharge or distance depending on your project needs. And as Molly said earlier, you know, this sampler is used to monitor or isolate depth-specific sediment needs, the stream energy, the distribution of the sand, the depth, and so forth. Then we have the equal discharge method. Usually in large river systems, if we're out doing that type of work, we have a ADCP with us because we're going to need to know the flow. And so if you do, then using one of the RDI systems or other manufacturers makes it fairly easy to compute your equal discharge increment. So on this slide, we've got, let's say, a million CFS. We're back in English, of course, not metric. I apologize. And it's pretty simple. So what we're going to do is we're going to use 5 sections, and that'll put 20% of the discharge in each section. So what we end up doing is then we sample in the middle of each one of those sections. So we end up with, well, this isn't a million. This is 500,000. 1, 2, 3, 4. Yeah, this is 500,000. So the middle of each one of those sections. This is actually a measurement from Vicksburg where this was divided out. And these are exactly where those EDI sections were laid out. As you can tell, this section here was much larger. The river's not quite as deep. It's not moving as fast, but it needs more area to compute the same discharge. The same with these sections. They're about the same depth and the same velocity, and so they're about the same width. This one's a little larger. But if you look at the backscatter, if you pull up the backscatter on the ADCP measurement and look at an indication of how the sediment is distributed across the section, really, these are individual channels that are being sampled individually. Does that make sense? So you broke a larger system up into several rivers. And so we sample in the middle of this section, in the middle of this one, in the middle of this one, and so forth. So the essentials needed to deploy a depth integrated sampler. You need a method of marking the equal discharge section points, ADCP, a GPS to mark waypoints that's fixed on the boat. These are fairly cheap nowadays. The mean water velocity at the sampling station. Of course, ADCP, I don't know if anybody still uses current meters. We have used them in the past. We still use them at times. Total depth at the station, of course, ADCP or other reliable sounder. I would recommend the ADCP. The correct nozzle size that you compute to use for your depth. The correct sampler, of course. A stationary static boat, that's hard to keep in one place. That's hard to do if you're new to this. And that's probably one of the key features that takes more of, it's more of an art for a boat captain to keep that boat steady in one spot. Because if your boat's drifting back, you're losing, you know, if it's moving at the same velocity that the water's moving, you're not going to be able to collect any sample. And so it's very difficult. We looked at the booms. And as I said, keeping a boat stationary in a wide, deep river without much of a reference from the bank, it's challenging and it takes practice. You know, drivers need to keep the boat positioned at all times and reference while the sampler's being deployed. You know, you can't drift side to side with those boats. It's very intense, especially in flood conditions when we're looking at 3.5, 4 meters per second, and we're lowering a 300-pound sampler off that size boat. Both motors are running, and they're probably at half speed. And that D99 is going to have probably about a 10-degree drift angle on it. even with that type of weight, at probably 90 to 100 feet. So this is kind of anatomy of an active moving boat sampling. Just to show you some of the odd end parts. This is the boom here. Sampler's here. He's got a handrail protecting him from falling over. This is the D96 going down. This is the flow. Let's see. This is the auto drive system on the back of the boat. We use side scan monitors that Humminbird and different manufacturers puts out back here, so that this sampler, this person here, can actually monitor what's on the bottom of the river while the boat driver sits here. We've got a third person in the cabin here. GPS. This is the external heading sensor and the pipe where the ADCP 600 hertz is mounted. So they're looking at live ADCP data here, and their communication to this person on the actual depth. What they're seeing, it's not changing. They're steady. You ready to go? Is the boat stable? Yes. This person lets the sampler down. If the depth changes, if the boat happens to drift and the bottom's moving enough that it changes, then the communication between the two crew in here has to be on the spot, because he has to know if the depth has changed 2 feet. Because if it has, the boat could be moving up and down. It may have drifted over 5 feet, which is nothing in 3,400 foot of a width of a channel. So it comes back up. This person takes the bag out, hands it to the person inside, and it continues. It can be complex, as I've been saying, than sampling from a fixed point. The use of these heavier samplers, keeping it balanced on these size boats, the way that we deploy them. Now, if it was on a larger 40, 60, 80-foot boat, not as much of a deal to keep it balanced. That boat's going to be wide enough to balance that. Monitoring the total depth from a moving point in the Mississippi with the moving bed that we have and the velocity that keeps some sort of dunes moving at all times, it's challenging not to drive that nozzle into the dune, the head of the dune. So monitoring the correct depth and bringing that sampler back up. If it were to go in there, you feel that sampler hit the bottom at 80 feet. It just kind of, you feel the boat just move a little. But if you're not going to really know whether or not it went into that sand or not, because you're going to expect some sort of sand in that bag, and inspecting for more than you expect, it's going to be impossible. So there are a couple of different methods to go about this. You can stop just off of the bottom. That takes a good bit of practice. When I say just off the bottom, a foot, maybe less, maybe a little more, depending. You've got barge traffic that's moving barges up and down the river. They leave these huge wakes. All of a sudden, your boat's up and down. You're going up and down. The bottom's changed a little bit, or they forgot to call the right depth out to you. The sampler goes into the sand. John Gray, before he retired, and I were talking about the best method, and the recommended method that came out then was to take an A and a B sample and compare the concentrations to know whether or not, if you're concerned about digging it into the sample bed and increasing the concentration of the sample, then it would be best to take an A and a B sample and compare them individually and look at them. And if the differences are within allowable, then you're good to go. If not, then maybe something's going on there. Floating debris is always a challenge. Submerged hazards, I talked about that a little bit. So locating the sample transect points using the EDI method. So years ago, we would take the ADCP and make a discharge measurement, and we would try to hold the boat on point on that discharge number after we configured it by hand. This was before we had an EDI program. And the Mississippi, the velocities surge somewhat. They can be reading live readings on an ADCP 4.5, 5.2, 4.9. It's active, it's live, and they're not just consistent velocities. So in doing that, what we started to do was, so this was the cumulative discharge only method, where we were measuring the discharge, computing where our stations were, cutting the Doppler back on, going back out and trying to hold it exactly on 640 or 64,000 CFS, cubic meter per second, whatever your units would be, is very difficult. We decided that we could refine that a little bit and start establishing waypoints when we put our own GPS system on there. It's made by one of the manufacturers, and where we could set waypoints in the river. And Molly showed a slide of some of our waypoints that we set. And so the way this works is we'll go across the section, make one pass, and we'll use that discharge to set our EDI points. Whether we calculate it by hand, we use the EDI software, we get those discharge values where we've got 5 sections, 20% sections. We're going to sample in the middle of those sections. So our percentages end up being at 10%, 30, at 50, at 70, and 90. So if you're doing it by hand, you just take the total discharge and multiply it times the percentage. It gives you your midsection points. So do that, or use the electronic EDI calculator, which does basically the same thing. You'll see it gets the same number if you calculate it by hand. We begin our second pass, and as we collectively accumulate the flow, we get to that value on the ADCP, we make a waypoint. And we continue this until we get finished with the measurement, right back across the same ship track that we were before, as close as we can. And so this is what we end up with. Over time, we end up with all of these points that we've marked. This is at 10, this is at 30, this is 50, this is 70, this is 90. Now don't let these features aren't there anymore. They're on the map software, but this is an island upstream that's not as produced here now. So actually the flow at this point was out over this bank to about this point. And so that's what's going on here. She's looking to make sure that we're on the point. We've got a boom and set up on the front. We've got another guy on the front that's sampling. This is our Doppler mount. We're reading live readings. And so once we do that, you can see our boat tracks. We go back and hold the boat on that waypoint, and when the captain says we're ready to go, then the sampler lowers the boom, lowers the sampler. This is another boat, that same setup that you saw before. The ADCPs are probably the most accurate for measuring depth. I mean, they're very expensive, and we find that they produce better than some of the manufacturers that may be selling the cheaper open market type sounders. They can be used and help with position. The side scans we like. We don't like it for the depth as much as because of the accuracy, but we do like it because we can see a clear view of the bottom. And you're moving with water that fast and that deep, things happen very quickly. And so you need to be very, very careful and pay attention to what's going on, because if those samplers were to get hung in something that was unknowing, a sunken boat, a log, or some sort of concrete off of a bridge that used to go across the channel. Anyway, so keeping it stationary with a heavy sampler tethered in a wide, deep river is always challenging. Takes practice. That we've gone across that before. So here's a comparison. This is from the Wind River, and this is the side scan. So on the side scan, when the boat is held still and static, it gives you a red circle and shows that it's not moving. When it shows it's moving, you get a boat symbol, and it points in what direction the bearing that the boat's moving. So here it's saying that the boat speed is 0. Well, if we look over here at the Doppler, it's 0.355. It's more accurate. It's picking up better information than this hummingbird. And so right here during this measurement, the boat speed's basically, we're still. The boat's not moving. The water speed is 8.8 feet per second, and the calculated depth is 80 foot, a little over 80 foot. So we're using the D99 on this sample, and this is a different day. But talking about the side scans, sometimes it's difficult because they make these things for fishermen to be able to see structure so that they can pick up on the structure under the water and do a better job at fishing. But we like to use it to just basically see the flat bottom. We can see this type of profile, but we keep it here, and the sampler can operate and look there and check to make sure that everything's clear. So it even shows the trace of the sampler going down. So that's what this V is. It picks up that sampler, and this chart is moving at a certain rate. It's scrolling across the screen, even though we're not moving. But it gives you a trace of the sampler. And as you can tell, this sampler went just to the bottom, and then it came back up. The drift angles are always challenging to try to figure out the correct depth, because if you're sampling in large velocities without a sampler with enough weight to keep that line tight and straight, because of the drag on the line, it's not as much just the sampler, but it's this cable that has drag on it. And so you guys are very familiar with this, so I won't bore you with any more information on how to calculate this. And I see that this has been incorporated into your software, so that gets another star. So transferring sediment samples from a bag to containers to go to the lab. Do you guys, when you collect your samples in your bags, do you take the bags to the lab, or do you transfer that into a container? Transfer it into a container? Okay. And are you versed with how, I can show you how we've been doing this. And so I have one here, but I don't think I'll go through it just to save time. As Austin Davis here in our center is doing this, this is about 2 liters of sample. And so we've got our samples here that we've collected. This is our boat driver in the middle, up front. And so he's been passed back the sample. He grabs the bag, shakes it up vigorously, and pours about half to 2/3 of the bag into the bottle. Then he picks it back up, holding it by the edges, by the seam that is not next to the bag. It's hard to describe. Shakes it again, and this could go on again till he feels like he's getting all of that material out. And then he vigorously dumps that in there. And after this is over, then we visually inspect the bag to make sure there's no traces. Other important consideration, some of the side scans, be careful, because they can create a noise signal that interferes with the ADCP signal. And so if you're making your actual discharge measurement, you want to have these side scans turned off. You can get some errors. Storing these samplers, these heavy samplers on the boat, they need to be chained down. You don't want these things rolling around. Communication and teamwork is the key with the boat driver, the rig operator. It's a team effort. It's a team effort. In most all situations, we use 3 members for taking a sample in this method. It's just safer. And for the main part, if the sampler that's operating the boom or the sampler, if he were to fall overboard by some unknown reason, and there were only 2 people on the boat, and the sampler is 70 foot into the water, what does that boat driver do? Does he leave the helm and let the boat just start floating and run over? So there's a situation there that you don't want to be in. So we use 3-man groups to do this type of work. It's just safer. The third man, when he's not doing something, he looks out for river traffic. He can be doing the paperwork, and so it just makes things flow. So that's basically it. Emergency procedures. We try to practice these. Cutting the cable. This is, we've started a class here that Molly talked, it's been going on for about 5 years. It's our large river sampling class. It's been very popular. People seem to really enjoy, they learn a lot from it, they take it back to their center, their office, and they use the information that we give them. These were the type of pliers that we were all using in case we had to cut the cable. In case there was a problem and we had to cut this cable to release the sampler. None of us are in love with these samplers. And so we don't want to lose anybody or a boat because of the sampler, so we'll just soon cut it. I mean, we don't want to have to cut it, but we will cut that cable. Lane here is very experienced on how quick things happen in a situation. And so he came out with getting away from this and this axle cut system that actually the Coast Guard uses to sever the cable when they're picking up things or when they're rescuing folks. If they get in trouble, it will cut a cable in a matter of about a second. There's no problem. So this is a girl, we've got a guy that's pulling the line out, and she's practicing seeing how hard it is to cut that cable if it's moving out. Now we do have breakaways on the reel that if it reaches the bottom of the winding system on the reel, that it's supposed to snap and break off. But if this becomes tangled or something becomes twisted, it's going to hang up. So other challenges, river traffic, keeping a boat on point, monitoring the velocity. It can vary, it will. In these larger systems, it's going to surge a little bit. Monitoring the total depth. It can change because of these things coming by you, equipment failure, it's going to happen, power failures. You can reduce this by using a generator and the inverters like I showed you. Real cable pulley misalignment, you just need to always look at your equipment to make sure it's in top shape before you get in one of these situations. These are some pictures of our large river class workshop that we hold in Vicksburg every year. We get together, we go over the equipment, we have folks that come and explain how some of it works, how you take it apart, how it can be fixed. We talk about the samplers in the parking lot hooked up to the boat, we demo them, and we get out on the river for 2 days. We let these guys take the sample, operate the rig, we'll demo 2 at one time, and then we turn them loose. We have an instructor and 3 students on the boat. The students even get to drive the boat. They get to feel what it's like to control a boat like that, trying to keep it steady with all of these things going on. They find that very useful because it's harder than you think. And so we have 2 instructors. We have a boat driver that's experienced captain, and then we'll have somebody on the back that's going over all of the other things. And so we'd love to have you guys come to one of our classes if you can. Thank you very much. Questions? Questions? Mississippi.
Eu só perguntei onde que é o treinamento para a Ana enviar alguém de nós lá, entendeu?
Mike, fiquei na dúvida. No caso, a recomendação de vocês é que o guincho seja instalado na proa ou na popa do barco? Porque eu acho que até na foto final tinha os 2 casos, tanto o guincho na proa quanto na popa do barco. Qual é a recomendação do SGS?
I recommend sampling off of the bow of the boat, if at all possible. Some of the boats that we already have the boom installed on the rear of the boat, those boats do not take bed material or bed load samplers. so they stay just within limits off of the back. It is easier to control these type of boats working off the front. You know, we just feel like it's safer that way. Most of our boats in the past were sampling off of the rear. The one in Mississippi was off of the front, and then it was switched to the rear. But I recommend the bow of the boat. The front of the boat with a rear cabin where the captain can see everything that's going on in front of him, and he's not turning, he's driving the boat only. So I feel like sampling off of the front with that first design that I showed you, something similar to that is much more. Because if something were to happen and that sampler was to become connected to a hazard, you could let that cable out and that boat's just going to act like it's anchored. It's not going to want to lift and pull itself over. So that's mine.
Ok. Outras são perguntas mais rápidas, só curiosidade. Você mostrou um slide que tinha um amostrador bastante antigo, que tinha tanto com um molinete hidrométrico e um lastro. Por acaso você sabe o nome desse amostrador antigo?
Yes. That was what we called the frame sampler. Right?
Yeah,
There,
that's right.
Right there, right there.
Yeah.
This right here. That was what we had as the frame sampler. We could operate it with a 3-liter or a 6-liter bag. We do not use these anymore because we've got the newer ones out.
Yeah, sure.
But I clamped on to the tail fin. Charlie Demas in Baton Rouge helped, I think, design some of this because of their larger depths on the lowermost part of the Mississippi River. I used this at Vicksburg back in the 80s with a current meter at the top. That was the way that the velocity was picked off to set the transit rates. And there was a hydraulic system on the boat that we were on at that time, so it was not perfect, but for the most part, I think we were mid-80s to 90% efficient with that sampler. You know, for the best that we could do in positioning our sections, that captain used the trusses on the highway bridge. And so he was, you know, so.
Ok. Outra dúvida, você mostrou outro amostrador ali, o P6-200. O Tim tinha mostrado o P6. Eu fiquei curioso porque esse 200.
The 200 is the larger of the two, right, Tim? The P6? That's right. Yeah, I'm not sure of the weight of it, but
It's a little over 100.
it's
This one is 200 pounds.
right.
It's another sample. Yeah, simpler. Ok.
There are two different models of that
Uh-huh.
sampler. I'm sorry I didn't show that model.
E a última pergunta aqui, para deixar outras pessoas participarem. Vocês, pelo que eu entendi, em grandes rios, vocês utilizam com maior frequência o método igual incremento de descarga, né, que é mais conveniente, e as amostras vocês analisam também separadamente por vertical, ou é mais comum misturar as amostras?
We have mixed the samples, but now we're in the mode where we're basically doing what you expressed the other day. If we're able to collect with the environmental conditions that we're seeing within 10% of the same volume, and everything looks like it's going as a good day, you know, then we will proceed with that. We have had samples come back that were just not enough. I was telling Tim earlier, it could be something with the bag, the way it's positioned on the nozzle. It could be the nozzle itself. Maybe that's a bad nozzle. We've changed nozzles. We've seen debris on the front of the nozzle. But basically the same way that you were teaching yesterday is about the same that we are analyzing now, to answer you more specifically, individual bottles, basically because of our one of our cooperators, the Corps of Engineers, are adding to some of our funding to get that distribution across the channel. Okay? And so we're doing the sand silt splits, and we're also doing sand size data for each vertical.
Oi, Mike.
Yes.
Minha pergunta é sobre a embarcação e a operação da embarcação. Vocês se movimentam na embarcação e vocês usam âncoras para parar a embarcação nos pontos? Ou é no motor?
We're only using the motors. We do not anchor to collect the sample. No, it's an active, it's a moving boat. So we're only using the motors. The captain is controlling the boat with the outboard motors. So the boat is not fixed to any point.
E para rios largos, o deslocamento se dá pelo GPS ou vocês colocam alvos nas margens?
GPS. The waypoints that I showed you that we mark as we're collectively accumulating discharge. Do you remember when I showed that slide where we'll make one pass with the ADCP and then we'll compute our sections, and as we're moving back across, we'll select a waypoint for that section. And we can set all of those points, and it gives us the option of coming back to the first section, or we can start on this side if there's barge traffic here. And so, it gives us options to be able to go, so we don't have to start over completely with where we are. Any more questions? Yes.
Pelo que eu entendi, quando vocês utilizam o método igual incremento de descarga, vocês primeiro fazem uma medição de vazão e, preferencialmente, já determinam os pontos de coleta. Mas, em alguns casos, vocês mesmos falaram, e a gente também tem a mesma dúvida aqui, é que tem uma variação na profundidade e na velocidade quando você vai para esses pontos. Não é mais aquela velocidade e profundidade do ponto que você determinou inicialmente. Você faz ajustes na velocidade de trânsito ou no tempo de coleta, tanto faz, em função dessa alteração ou não? Continua usando o que você calculou inicialmente?
That's a very good question, because we do both, but for the most part, we use for the numbers that we actually take the sample. Our EDI software is a guide, and that software will take more ensembles to average that velocity out that you should be using for your transect. You follow me? But we also use the live readings. We're looking at the live readings as well. And so sometimes that can be difficult, but sometimes the velocity has changed from when we made the first pass and we're back to that area like you described. So it's kind of a give and take. We try it, and so what we're thinking is maybe the mean velocity for that section, and we'll send the sampler down. If we get appropriate volumes and we weigh the sample, we don't measure it with a graduated cylinder. There's two separate methods that you can get the volume from that bag. You could pour it into a 4,000 milliliter graduated cylinder and get the volume, or you can take the bag and use a 4,000 gram weight, a scale. The mass is 1-to-1, basically. Now, if you're looking at some of these larger sediment stations where Molly was talking about the concentrations 44,000, no, I wouldn't suggest that because you've got a lot of mass there. At Vicksburg, we're looking at somewhere between 3 and 4 and 500 milligrams per liter, average. That's a whole different presentation that I would love to give you about the sediment on the Mississippi River. But did that answer your question for the most part? So we use the live readings. And we try to get that mean velocity there. It does change, but I think that's true. That's actually what's going on. But we have compared it to both, and if our boat is static and everything is working the way it should, and our sampler and our nozzles are good, they're not like the ones that I passed around, that have a nick on them, and we're all set. We end up with good, I mean, it's 100, 101%. We can have 90% efficiencies. We're good to go. So just to go over a really quick scenario, we're on point and we're collecting a sample. We have to collect 2 or 3 verticals to get our water quality and sediment. We don't split our sediment samples off. We take it as is, and then the whole volume goes to the lab. We used to use a method where we would pour it into a churn and then churn off, mix up, composite our sediment, but now the entire volume goes to the lab in an individual container. So the way we would do this is we would send the sampler down and collect that volume. We time it with a stopwatch. We get the time, we know the nozzle, we know the velocity, the stream velocity, just like the other day with the calculating efficiencies. We take that bag and put it into a container that's tiered on a weight on a counter in the boat. We weigh that sample. We get a general efficiency because the boat's moving and we're trying to weigh it. The numbers on the scale are moving. We can get a general efficiency with that and lightly sketch that down. But what we do is once we get those samples back to the office, we weigh them in the lab and get a true weight, and we can adjust that efficiency. And it may go down, it may go up a few numbers, but it's usually a general, very good efficiency number. And so once we establish that rate, then we use the same transit rate and send it back down to get the second vertical. If that one did not calculate, we start over. And so normally we can get a fair to a excellent efficiency on the first vertical. And so the FISP report says memo wanted 3 efficiencies done that are at a certain rate, and then you can continue. But what we do is we kind of, Molly, we've modified that. It works better for us, but we're getting more efficiencies. We take an efficiency for each drop. The first one is the sediment. If it's good, then what we do is we use it for the water quality. And so we go to the next one. And so it doesn't take that much more effort to calculate an efficiency 5 times than it does 3. But that way we know if the first one was good, the second one's good, the third one's good. So that's basically it. But that was a very good question about the velocities because, yes, they can change. And sometimes that's troubling. Sometimes we have to work with it. We don't like the volume we got. We don't like the efficiency. We may look at the velocity there. Maybe it changed a little bit. Maybe we're picking it a little low. We try to go on the lower end of the velocity so that we're at the lower tier of that efficiency range of that spear on the charts so that we're on the lower part of that. And we intend to then be able to achieve the efficiencies that we're looking for.
Mais uma pergunta? Então, obrigado, Mike. Vamos fazer um intervalo aqui de 15 minutinhos, depois tem a apresentação do SGS, do time. pessoal. Vamos lá? Vamos lá, pessoal? Quando estiver pegando sol, porque tá muito frio aqui dentro. Saudade. Saudade. Pessoal, antes da apresentação do time, deixa eu só perguntar. Ó. Depois no final do dia de hoje, a gente vai explicar mais ou menos como é que será a dinâmica amanhã na aula prática, né, demonstração prática. O da quinta-feira a gente fala na quinta-feira de manhã. Como amanhã é todo dia de campo, né, à noite a gente não tem condição de fazer nenhuma confraternização, nem na quinta e na sexta, boa parte de vocês já pegam um voo, inclusive o pessoal do SGS. Então, o dia que tem para alguém fazer alguma confraternização é hoje. Né? Como amanhã tem aula de campo, né, é lógico, cada um aqui é adulto, pode fazer o que quiser. Mas, né, como a gente vai sair 8 horas em ponto daqui, né, para ninguém perder o transporte, a ideia é que a gente vá aqui para um bar, restaurante, aqui no shopping, Parque Shopping, aqui pertinho aqui da Ana, daqui mesmo, só de 6 às 8 horas, a gente vai terminar aqui 5 e pouca, né? Fica de 5 até 8 horas. Aí lá, como é que é o sistema? É um restaurante, tem tudo. Quem toma chopp, alguma coisa, custa R$50, você toma 5 chopp, qualquer bebida que você queira, e tem direito lá à mesa de frios, né? No Pinguim. Né? No Pinguim. Que aqui é pertinho, que se for para o hotel ninguém vai, aqui fica mais fácil. É, obviamente, quem quiser ir. Só para eu reservar a mesa, ligar lá para o restaurante e reservar a mesa, quero só que levante a mão quem pretende ir. Né? Só para ver o número de pessoas aqui. Né? 6 às 8. Quantos?
Levanta a mão, Joana. Levanta a mão, Joana.
1, 2, 3, 4, 5, 6, 7. Matheus, levanta a mão, Matheus. 8. Mais ninguém? Ricardo? Não? Ninguém aqui? 10 pessoas? Tá bom. Ok, pode ir para 15. Ana Carolina. Ok, tio.
All right, now I'm going to talk about bed load, bed material, and reservoir. Is this on? Yeah, okay. Bed load, bed material, and reservoir sampling. And there's sometimes confusion between bed load and bed material. So hopefully after this presentation that there's no confusion on that. But if there are, just let me know, ask questions. All right, so bed load sampling is essentially getting at the material that's either saltating or rolling across the bed. It's actually it's material in movement. So similar to what we've been talking about, this collecting suspended samples, we have samplers that will collect the bed load, the material moving along the bottom, because as you know, the suspended samplers don't reach all the way to the bed. So this is, as I said, material moving on or near the stream bed. It can move much more discontinuously than the suspended sediment. So, but to take that into consideration as we think about the sampling, the material finer than 0.2 millimeters is rarely ever found on the bed. And it's I think Walzon asked this morning, Molly answered, you know, it's generally between 5 and 20% of the total load, depending on your system. But it could be 90% of your problem that you're trying to address. So in some systems, you may want to measure the bed load. So spatially, it could vary, just depending on the shape of the channel and things, much more than the suspended sediment. Here you see, uniformly varies, uniform, consistent, or kind of erratic or unpredictable. That on here is the mean bed load transport on the x-axis and cross-section distance on the x-axis. So it's just giving you 4 different scenarios there of how the bed load could move. And there's a number of others of how it could move, but it's gives you a flavor for that. It's a bit different than the suspended sediment. And then it not only spatially, but it could vary over time much more. It can, the particles, as you can imagine, when they're saltating and things, they might get stuck behind something and not move for a while, and then all of a sudden be in movement again. And that's what some of the real data here that we see. We've got bed load mass in kilograms, and then time. So you can see that it's fairly erratic in this situation. And over here we have the same thing on the y-axis, incremental bed load in tons per day here. And then this is the station in feet. So this is more across like the last slide, the spatial variation across the cross-section. And the dashed lines are the actual bed load movement. So you can see here it's kind of in this one here is kind of in that erratic category, and this one at a different time and a different bed load pass is not quite as erratic, more uniform. So this is a really nice schematic of what we're actually measuring. With the suspended sampler, we go all the way from the top, and then you don't want to dig this into the bottom. We've got some videos later this week of this digging into the bottom, and the flume really causes a problem with the sample that you get. But this sampler, the bed load sampler, we do want to go to the bottom, and it collects the material that's saltating along the bottom. And then, but we still have an unmeasured zone that doesn't measure in between. So you're still not quite getting the total load, but it's pretty close. So when we think about bed load measurements, we have another sampler efficiency calculation, but it's different than the efficiency that we're talking about with suspended sediment. This one we're actually talking about the mass of the sediment collected by the sampler, and then divided by the mass of what would have passed the nozzle area had the sampler not been there. So you can think this is really hard to figure out. There have been some more recent lab tests that there's be a paper coming out on all the different bed load samplers and the efficiency, because that's pretty much the only way to really get a feel for how efficient the samplers are in different materials, the bed load ones. But again, with this, we are looking for a sampling efficiency of 1. So I'm going to mainly talk about the pressure difference samplers. There's something similar called the box or basket trap samplers, and then the slot or pit samplers. And those are physical sampling methods. And then at the very end, I've got one slide on surrogates for bed load measurement. So the pressure difference samplers, this is what they look like. They have a nozzle similar to this, but they have this outlet area, and they call this the nozzle area ratio, and that was developed by the FISP and tested to try to get that sampler efficiency of 1. So the different sizes in inlet and outlet, and there's a recommendation of at least the nozzle area to be at least twice the size of the largest particle that you're trying to collect. So here's the FISP BL84. It's a 3x3 inch nozzle, 32 pounds. Although you can hang, similar to the other samplers, you can hang the weights on it to make it heavier and faster velocities. And it has the nozzle area ratio of 1.4. This is the same sampler, essentially, same nozzle area ratio. It's just the handheld version of it. And you can see here, let's see. Yeah, in this is a good example where, you know how she has it kind of tilted up. When you want to lower it to the bed, you don't want to dig into the bottom. So when you lower it, you want to kind of have it tilted and lower it down so that you don't dig the sediment out. You want to just set it gently on it. So as people worked in bigger rivers, the 3x3 inch nozzle was not big enough for them, so they started developing these other samplers. They're not technically FIST approved, but they have the same nozzle area ratio, and as part of this new lab testing, they've been tested, and then the FIST will make a recommendation whether to approve it or not. But as you can see here, the opening on this one is 4x8 inch. So this is, and the Elwha is a river up in the northeast or northwest part of the U.S. So much bigger particles coming down. They needed a bigger sampler. And then this one is even bigger yet, 6x12 inch nozzle. Call it the Toutle River sampler. So if some of you are familiar with the Mount St. Helens explosion in the 1980s, this sampler is sampling sediments that received some of those sediments from that explosion. So there's a lot of sediments coming down. The Hubble 5, which I don't know much about or know anybody that's using this. Do you know much about this one, Molly? Just another one. It's actually the same size as that one, as the Toutle River. So this is one I want to talk about because it was kind of one of the original ones. It has this nozzle ratio of 3.22, and in the recent flume tests and things that I was talking about, it actually has a problem with. So it has a wide nozzle ratio, and it actually will suck in sand from the bottom of this and from around. So then they have videos and things showing that, and so it takes in too much sample. So the FIST is not recommending the Healy-Smith anymore. So there's some things to consider as you think about lowering a sampler all the way to the bottom. One, you need sediments that are firm enough that the thing is just not going to sink through. Like think about maybe a really fine grain system, which you wouldn't be really probably concerned about bed load anyway, but you can think some of those bed sediments really soft and the sampler would just sink into the bed. Another big thing is it smooth enough? So if you think about lowering it to the bed and you end up, say, on a rock or something, and you can't get that thing to sit very well on the bottom, that could cause a problem. And the stream velocity, you can get by with adding more weight to try to deal with that. The one thing that you might not get by with, so organic material in their stream, if you have leaves or debris coming down, that would clog the bag before you even get to the bottom, could be a problem. So if you thought the EWI and the EDI method for suspended sampling was confusing, this is a whole nother level of kind of confusion in this process. So actually the first one there, the 20 verticals, EWI, 2 passes. So you're basically hitting the bottom 40 times. So you're going, it's very similar to the EWI that with the suspended sediment. But they have these other options because as you saw in some of my opening things, the bed load can be fairly erratic. So they make it a little more flexible where you can vary what you're doing. In particular, say this one here, you can go X number of verticals evenly spaced, at Y passes. So that will say you don't think 20 is too many or maybe not enough. You can vary that, but it's still the same as you're going to hit the bottom 40 times. Or the I've got a schematic that shows this one a little bit better. But in each pass, or each time you lower it to the bottom, you're usually going to set the sampler there for 5 to 60 seconds. Similar with the suspended sampling, you can go and test your how long you want to leave the sampler on the bottom. You don't want to fill the bag over 40%, so you go to an area where you think the sediment on the bottom is the most, and you could test kind of your time. If you don't get much sediment after, say, 60 seconds, then there's maybe not much going on in that vertical or maybe in that river at all. And then the other thing with these tether lines are very important if you can do that. And I didn't come up with this schematic so it on this animation, but it kind of gets at what's going on. So if you're hanging off a bridge or off a boat, and you don't have what we call a tether line, which is your sampler can go into the bottom. So this is what a tether line is. So you have somebody on the upstream side trying to hold it from swaying out so far. On a boat, you don't really have that option, or you could, just by the boat moving itself, it could dig the sampler in, or you could have debris. Yeah. Worst case scenario there. So I'm not going to focus on these names. So this is what I was talking about before, the 40 times to hit the bottom. There's 3 different methods. I'm not going to talk, the names are a little bit confusing. So the main thing here is you're going to go 20 verticals. They're equal width, and you're going to do 2 complete cross sections. And this is lined up, set up the way Molly had described the EWI. And so here's an example where you could do, instead of 20 verticals, you do 4 to 5 verticals, and then you do more of the cross sections. Again, with the bed load being more erratic and irregular, it takes a bit more to get a representative sample. And here's an example of, unequal width increment. So this is where you can say you have a large part of the river where nothing is moving on the bed, and you confirm that with your field note that you lowered the samplers, but all the action's over here. So and you want to focus on that section, and this is a really wide river, so that there's some flexibility in our techniques and method that you can actually do unequal width increments with bed load. So with the bed load, I mean, depending on your project goals and things, what you want to do with those samples, analyze them for particle size, or just you just want the mass or whatever. It's kind of up to your project goals. So with any sampler, there's a conversion factor to get what you're looking for, and I won't go through this too much, but I mean you're essentially you have a time that you're on the bed, and then you want to get to something, a mass or something that you can quantify that will, as we talked, if you're taking a suspended sediment sample, now you got your bed load sample, so then you can get a total load. There's computations, and there's more information about computing that in the Edwards and Glisson that Ozan talked about. And depending on the method that you use, calculated a little bit differently. So now I'm going to move on the pressure difference samplers to the basket or trap samplers. So as you can see with this method, it has to be a weightable stream and something that you can get in and put these baskets in and leave them over a certain amount of time and assume that the bag is not going to fill up until an event. So as you can see with this sampling site, it's relatively clean water probably until there's a storm event, and then you would get the bags, or the bed would become mobile and fill up your bags, and then you come back after the event and collect them. And this is another method of where it's literally there's slots or pits, and as the bed material rolls across, it falls into the pit, and then you can weigh that, what's been retrieved in the pit. And then lastly, surrogates. Molly touched on this a little bit this morning. You got the hydrophone, which is literally listening for rocks and things to clank. So as the bed becomes more mobile, you will pick that up on the hydrophone. And if you do over a series of events, you have your physical sample with the samplers that I just talked about, and then you can relate that to the hydrophone noise that's recorded. There's the same principle with these the plate system, where it's actually the materials hitting the plate being recorded, but you have their physical samples to compare to the noises that you hear with on the plate. And then if you're working in a more of a sand bed system with large dunes, so something like the Mississippi River, where there's methods where they look at the dunes over time. So this would be time. So this is elevation, and this is longitudinally down the river. So the dunes at time 1 would be this blue line, and then you come back a little later, and at time 2 the dunes have moved. So there's a person at the Corps of Engineers that has really done a nice job of developing this. We're actually going to be meeting in the fall to discuss with him, maybe approving this as a FISP method. And then in 2010, this is John Gray. They had a bed load surrogate monitoring kind of workshop thing, and they summarized a lot of these methods in there. The method I talked about here is probably, I think, is in there, but it's more developed now. And if you guys are interested, you can just email me, and I'll get you in contact with the right person. All right, so now moving on to bed material. All right, got an easy quiz. The first sampler I'm going to talk about is so for another prize keychain. Anybody guess what the BM H53? Say it again. 1950. There you go. All right. So in that same report we were talking about before, we have bed material samplers, and here the BM H53, which is the one I'm going to talk about first. Again, weightable, handheld, developed in 1953, and then there's some that are on a hand line and reel. But the important thing here is that it's very different than the bed load samplers. Right? This is just physically going down and grabbing a sample off the bed. So it's not trying to get transport of the bed material. Or the bed, what's moving along the bed. It's just going down and grabbing a sample. So why would we do that? Here's a number of different reasons. The main one I run in is the very first one, to estimate bed material or bed load transport from equations. So a lot of the different models and things, the main driver is the bed material sample, and usually it wants a particle size distribution of that bed material. So it's fairly important. And so you think out of it, so that's the bed material is the input to the model. So then you run this model, and then it tells you what the transport is. And so if you have your suspended sediment sample and your bed load sample to get as physical measurements, then you can look at how your model is doing compared to what you actually measured in the stream. So that's kind of how I think of these are as different. You know, the bed material is the input to the model, the suspended sample and the bed load sample are the kind of verification of how your model is doing. All right, so it's literally, in this case, this one's a piston type sampler, so it has a little piston in it. You push it down, and when you pull it up, the suction from the piston being pushed up helps you hold the sample in it. Looks something like that. There's some, as you can see here, this would not work for coarse sands and gravels. It works more for the finer sands and fine grain like silts and clays. This one here is more of a scoop. So this mechanism here is actually pushed up in there as you lower it to the bed, and then it comes out and it scoops a sample. So this would work better for if you had fine sand or sand and fine gravel. Now, as you get to the bigger river systems, you need something bigger. Same concept, though, right? It's got a scooper at the bottom that you can lower down and faster and deeper flows. So there's no more H on it, so it's a heavier one. And this, you got to be careful of these. This is improper use of the sampler. You don't want to get your hand caught in it. But this shows a good schematic of how it works, right? So when you lower it, the tension on this cable keeps it closed, or open is how you think of it. So it keeps it's open, and then when it hits the bottom, the scoop comes up and collects a sample or fingers, whatever. But you can see here that as you get to coarser, gravel, cobbles and things, this is going to have some problems, right? So people over the years have invented different things. This is one example. They call it the Cooper scooper, but you can see it here. It's a little more flexible. You can get bigger material from a river. And then if you're working in a wadable stream, the Forest Service has a really nice document on, maybe some of you've heard of woven pebble counts and things, where you actually go into the river and do either a systematic or a random walk, and you literally grab particles, gravel, cobble, and you take their size, record their size of like 100 of them, and then that gives you a particle size distribution. But you have to be able to get into the water and get your sample or grab your samples. But it eliminates having to send anything to the lab. All right, so reservoir sampling. Walzon was wanting to have a little bit about reservoir sampling, so we threw some in here. A lot of this, I think, Art Horowitz talked about some of this the last time in 2015. But it's important as you get into the reservoirs and filling of reservoirs with sediment, it's good to think about this. So the sediment coming into the reservoir is kind of partially part of the lifespan of the dam. I mean, there's the physical attributes of like the concrete and how long that'll last, but if it fills with sediment before the concrete's bad, then your reservoir is, and what it was built for is no longer any good. So you got to think about the sediment that might be coming in and being trapped. So ideally, you have one of your stations upstream where a reservoir is going to be put. And so you know, have a good idea of this sediment that would come into a potential reservoir. You know, as you build that, or as it's built, then it may change depending on where if your station is fairly close to the dam, then those rates are going to change over once the reservoir is built. Okay, so prior to kind of what I said before, you know, it'd be nice if you have sediment samples before or what's going to come in. But once it's built, then you have other options besides just monitoring suspended and bed load upstream of the reservoir and downstream of the reservoir. And those include, you know, simply the bathymetry, so bathymetric surveys, or seismic reflection, or coring. And so this is what I'm going to be talking about mainly. So on a 5 to 10 year interval, you might want to do something like the bathymetric survey or some of these other techniques. Whoops. And getting the volume is fairly straightforward. But getting the mass is another story, because you need to know the density of the sediments. So if you think about a bathymetric survey, so that's just, you know, simply when it's built, you get the profile and of the reservoir, and then after a certain number of years, 5, 10 years, you come back and you survey the reservoir again, and you can get the difference between the two. You get a volume of your sediment. But then you have to think about and that may be all you need, but if you want the mass of what's behind the dam, or you want to use that to calculate, you know, what's been transported in, then you need the mass of the sediment. So then you need the density, so then you need some way to actually go down and get some sediment from the reservoir. And so, you know, you can come up with different schemes, just like with suspended sediment sampling, the EDI versus EWI. Well, you can come up with, you know, kind of a systematic grid or some type of random sampling. Or if you know what material is in the reservoir. So a lot of times this is the upstream part of the reservoir. The sediment comes in, the coarser material will drop out. So you have the sands, the silts, and then the clays. So if you know something about that, then you could modify your sampling to account for the differences. So maybe you wouldn't have to take as many samples if you kind of know what different particles are in the different parts of the lake. So if there's a few different ways to go down in the lake to get a sample. And now we think about a lake. So you could take one of the other samples, like the BM54 down, and it would collect a sample similar to this. But if you think about a lake, the velocities aren't there and things. So you can get by with some of these other samplers that would just drift down, and if you're in a river setting. But in a lake, they work fairly well. And these are essentially, it goes down and closes and takes a sample. Just another type of that sampler. This one's kind of more similar maybe to the BM54. If you're interested in, or maybe say a lake's been, or a reservoir's been in place for a long time, so you don't have an original survey of the bathymetry of the lake, this might be a way to get some information. The seismic says you can have different acoustic signals go down, one that would penetrate the sediment and one that would not. So then you can get the bottom, the original bottom, and one that would get the top of the softer sediment that's been deposited. The one thing with that is the original this method works only if the base of the reservoir impoundment is hard enough to reflect sound. So if the original bottom of the reservoir, which in most cases would be the case. All right, so if you need, let's say there's a lot of sediment, you need more than just a surface grab of the sediment. Coring is an option. And there's two different types, the gravity core or the piston core. And if you're looking at density, these two are the best. The big difference between the two, one only goes to about 2 meters. The other one goes to about 10 meters. So this is a schematic of the gravity core. You have your fins to help make it drift down nicely. You have the weight, depending on the weight, and then you have some type of core that catches your sample. And this is the cutter bit. And this is the piston core. So it's a heavier weight. It has a trip core that goes down. This is over time, so this is time 1, time 2, times 3. So as this digs into the bed, triggers a trip arm, and releases this sampler to go and take again, it takes a deeper sampler than the gravity core. That's just some of the details of that arm. This is a photo of one. And so I thought it'd be good to do this exercise from art. And I think, let's see what time. Yeah, we'll just go through it together. So on January 1st, 2009, this dam was built. So this is a hypothetical river and dam. Fortunately, the intelligent hydrologist installed the stream gauge and collected sediment data downstream of the newly filled reservoir beforehand. So they had some prior data, and then they have data after the construction, essentially. And this is the capacity. We need the capacity of the dam. And then we have how much came down in the 2 years after the dam was built. So then we get the volume of the sediment trapped versus the volume of the reservoir is the percent filled. If you crunch through these numbers, yeah, maybe somebody crunches that. We can get a percent filled. Times it by 100 to get the percent filled. We have a number. I should have gave away a keychain for this one. So it's this is the numerator and then the denominator here. Have a number? Yeah, so about 1%, little over 1% is filled in 2 years. So then as it says here, this is going to be very approximate. You could do bathymetric surveys too to verify. But then if you want to start thinking about when will 25% of it be filled? You have some numbers to start going on. So that'd be, using this equation, to be about 12 about 12 years, 25% of it would be filled. And with that, I'll open it up to questions.
Alguém tem alguma pergunta? Ricardo.
Late in the day on the second day.
Então, eu tenho aqui umas perguntas. Tanto relacionado, Tim, com um bed load como material do leito. Estava pegando algumas notas aqui, não sei se você mostrou isso na sua apresentação. O protocolo é misturar as amostras ou analisá-las separadamente? Tanto para bed load como para o material do leito.
It's project dependent. So if there's some reason that you need to know what's going on in different parts of the river, then you could analyze them separately. I think in the most operational situations, it's composited, but especially for bed load. But bed material is a little different. Generally, like for the models, compositing, I think would be fine, unless you want to model certain parts of the channel differently, or want to know if it's very vastly different across the cross section. You want to keep it separate. Molly, you've done probably more bed load sampling with whether to composite or.
Yeah, Tim is right that it really depends on the objectives of your study. But what the lab will do is they will just report the total mass. So if you give that to them in a big bag all combined, they'll give you the total mass. If you give them each station individually, then they'll give you the mass at each station. And then the calculation just takes in, the calculation for bed load takes total mass. So you can add up all the individual stations if you want total, or you can send them one sample and analyze it together. So it really, it just depends on if you want to have an idea of where bed load is moving in different parts of the channel.
Mais alguma pergunta?
Continuando na questão de amostragem de sedimento do leito, né? A frequência que se vocês fazem nas estações lá, e percentual que é feito, e qual a frequência que é feito essa amostragem? Uma vez ao ano ou...
Yeah, good question. It's really project dependent. So there may be a project that wants it very often, like during certain times, daily or weekly or something like that. That's fairly rare. It's more with bed load measurements. What would you say, Molly, about on a average for?
It depends on, so often it's less frequent than suspended because often there's a threshold of flow or discharge at which bed load will start moving. And so you may collect suspended over a full range of conditions, but there's a flow or a discharge below which there's no bed load movement. So oftentimes it's less frequent than suspended. But I would say at sites where there's a regular bed load sample collection program, I'd say, 6 to 8 samples per year is normal. Depends on how much it varies and what the objectives of the study is. But I'd say that's somewhat normal, 6 to 8 or more per year.
E a quantidade de estações ou percentual de estações que é feito na rede hidrometeorológica de vocês?
Yeah, unfortunately, I don't have a number for that for you right now, but I would guess it's probably no more than 20% of the stations that we collect suspended material. So if we collect, say, on average, 1,000 stations for suspended, I mean, you're talking 200, 250 stations at the most where we collect bed load, and that's probably a little on the high side. But you would be surprised at how hard it is to determine how many stations we have in USGS based on our database structure. It's strange, but that would be my estimate.
E quando é feito bed load, faz também bed material? Or...
Not necessarily. As Tim noted, bed material is probably even more rare. I think people typically will collect bed material if they're interested in what's available to be transported for like sediment transport studies and hydraulic studies and things like that. So it's pretty infrequent that we will actually collect bed material.
Once a year?
Maybe once a year, yeah. Yeah, that's probably about right. Yep.
Que tem trabalho, principalmente com material mais grosseiro, rios com cascalhos, né? Que algumas metodologias que a amostragem obriga uma amostragem muito grande, um volume de 100 quilos, às vezes. Eu achei muito grande isso aí para coletar alguns tipos de métodos de coleta de bed material. Não sei se qual a metodologia que é usada na coleta do bed material para vocês.
We don't have I don't think the labs give a minimum, but it's certainly not that much. I mean, what the lab will do is they get it, they dry it, they weigh it, and then they sieve it. They do the ROTEP, they do a sieve analysis on it. And typically, I mean, if you've got bed load, you've got at least enough for them to do those things. I've never had them tell me I didn't have enough material to do a bed material or bed load sample. Have you, Tim? Have they told you?
Well, were you talking about bed material maybe?
Bed material or bed load?
Yeah. So in the Forest Service report, they have some of those numbers where if you, depending on your largest particle, how much you would need to bring in to have a representative sample. But in a situation where you can't wait and do the worm and pebble count, I think you just have to do the best that you can in the river system, because you're not going to get the amount of mass that they're requiring. Yeah.
Okay, thank you.
Eu tenho uma pergunta para o Walson, na verdade, sobre esse tema, talvez possa me ajudar. Porque nós temos algumas estações, né, no São Francisco, e uma numa afluente do São Francisco, que faz coleta de fundo, né, e não tem, inclusive a gente está em fase de planejamento, né, Arthur está aí? Tá. E não tem orientação no planejamento sobre a questão da coleta de fundo. A gente só tem da coleta de sedimentos em suspensão. E aí eu queria saber se nesse monitoramento de seção, se tem algum procedimento no sentido de quantas amostras por seção, se tem tem que fazer algum estudo de cross-section para avaliar quantas amostras, porque a gente está num moto contínuo tipo Alto da Compadecida, né? Só sei que foi assim e a gente está fazendo, entendeu? O Ademir tem bastante experiência nisso, ele quem sabe onde é e como é. Só que no planejamento não tem nenhuma orientação em relação a isso e a gente precisa de uma determinação, quantas vezes, que método, se tem, se não tem, não sei.
Na realidade, assim, em termos da nossa rede, realmente não tem orientação da ANA por enquanto, né? Em 2007, em 2006, quando a gente fez aquele planejamento, foi mostrado aqui ontem, da rede sedimetométrica para coleta de sedimentos em suspensão, a gente já pensava, né, nos anos seguintes, já implantar a coleta de material do leito em algumas estações, né? Só que não foi possível fazer esse estudo, a gente já sabia de cara que não iríamos coletar nas 500 estações, porque não tinha justificativa para isso, ia pensar numa metodologia para selecionar algumas estações, tanto que, não sei quem está mais tempo na rede, pelo menos nessa época de 2007, foi adquirido no mínimo um amostrador ou 2 por unidade, foi encaminhado para cada uma, porque no que pese que a gente não estava abordando isso nos cursos e não tinha metodologia ainda, tanto para coletar, quer dizer, ele já existe, mas a gente não tinha pesquisado, estudado ainda, a gente não passou isso para vocês, né? Infelizmente, naquela época, eu saí um pouco da parte de sedimento, aí isso não avançou, mas a gente pretende fazer isso talvez no próximo ano, no máximo em 2021, não é? Aí seria basicamente isso. Ter algum critério, alguma metodologia para selecionar alguns pontos para a coleta de material do leito, daqueles onde a gente tenha uma possibilidade maior dessa carga do leito ser um percentual razoável em relação à carga total. Aí, nessas estações, coletar material do leito para poder estimar a carga do leito e a gente ter essa carga total. Mas será feito nos próximos anos. Aí tem que fazer todo um planejamento, inclusive, da parte do laboratório também.
Alcio, essa parte do planejamento tem que incluir exatamente as mesmas perguntas que você já fez, né? Se é para fazer por vertical, se é para fazer composta, quantas vezes ao ano. Que para a gente é mais importante saber o que a gente tem que fazer com essas amostras no laboratório, tá? Porque realmente essas orientações, acho que até as unidades não sabem, que eles acabam recorrendo a gente no laboratório. E as decisões não é do laboratório, né? A decisão é do responsável pela coleta ou responsável pela operação da rede, né? E a gente acaba fazendo ela composta. A não ser que tenha alguma orientação, alguns casos, mas aí já era pessoas que estavam fazendo algum mestrado, algum doutorado, que nos pediu para fazer separado, em situações mais específicas, né? Ok?
Tá bom.
Eu tenho uma curiosidade no seguinte. Se vocês fazem e a partir de que momento a gente deve considerar, por exemplo, na coleta de leito, né, de material de leito, uma situação que a gente chama aqui de fundo móvel, moving bed. Em que momento que isso pode se tornar um interferente? Vamos supor, numa situação normal de fluxo, que não está acontecendo o fundo móvel, que a gente chama, que inclusive a gente mede, ele afere justamente para descontar esse falso positivo na descarga líquida. Eu quero saber se isso deve, por curiosidade mesmo, a título de conhecimento, se isso deve ser considerado, inclusive, na quantificação da minha coleta de material de fundo. Por exemplo, numa situação em que está tendo uma descarga alta, um fluxo muito atípico, muito anormal, e eu tenho que fazer a coleta de fundo, material de fundo. Ou seja, está acontecendo fundo móvel. Isso é considerado? Porque a gente sabe que uma parte desse leito ele vai estar em movimento, ele vai estar em fluxo. Ou seja, automaticamente ele não vai ser coletado no momento da captura, lá, independente do equipamento que a gente está utilizando. Eu queria saber isso, se isso é considerado, tanto para a gente, serve para a gente também, Alcio, se isso deveria ser considerado nesses casos de fundo móvel, entendeu?
Yeah, so it gets down to what's your biggest need. Say the moving bed at normal conditions is just 5% of the total load. So the suspended load that you're already measuring is 95%, and a lot of our stations that's good enough. We don't, that 5% that we're missing, we don't worry about because we're taking care of 95% of the load. It becomes more of an issue, say 20% of your load is the bed load, and it's causing some problem downstream. It's filling the reservoir faster than what they anticipated, but your suspended load measurements are not taking into account. The dam operator is saying, well, you're telling me this much sediment's coming down, but our reservoir is filling faster than that, so what's going on? So then you might want to go back and think about then that a site like that doing bed load measurements where there's concern. It's kind of when I start, it may be only 10 or 20% of the load, but it could be 90% of your problem downstream. It's filling something in that is a problem, and maybe the suspended load is just bypassing the whole system, but that bed load it's moving along until it hits something like a reservoir, and then it's just there, and it's causing a problem.
I think maybe what he is asking is if he has moving bed, is that a good time to be collecting bed material? Is that what you were asking, or no? If you want to collect bed material and you've got bed load moving, is that a good time to collect bed material? I think that's what he was asking, but I'm not sure.
Não só se é bom momento para coletar, ou se tendo que coletar, e se existe alguma metodologia específica que considere a velocidade desse fundo móvel.
So the question's more, when's a good time to collect bed material? No?
Maybe. Pode ser, mas é o método. Qual seria a metodologia, caso eu tenha que fazer a coleta? Ou se há uma metodologia, se ela recomenda que não colete e a gente não faça a coleta e espere. Mas se há alguma metodologia relativa a isso, para coletar e tendo que coletar, se tiver que coletar, se tiver essa necessidade, se tem alguma metodologia que considere a velocidade do leito.
So you want to take it?
Well, I'm not sure I fully understand, but I think the question is, are you more interested in bed load or bed material? And if you are interested in quantifying the moving bed, which is bed load, then you would need to implement bed load sampling techniques to capture that. So that could be the pressure difference sampler lowered to the bed and collecting that sand. That could be an approach to collecting that information. But if the goal is to more capture what's deposited on the bed when you have some bed load moving, then a better approach might be to wait until lower flows when you don't have moving bed to get a bed material sample using, say, the BM54 or something like that. Does that answer the question or no?
Maybe it gets at, so if you have moving bed and you want to capture that would fall under the bed load samplers. So the BL samplers will do a good job with that. And Molly's, I think that's a good example of if you want just some bed material of just what's down there, not moving, it's better maybe to wait till a lower flow and then go to and get that with the BM samplers. So the bed load samplers versus the BM. So I think what you're wanting is the bed load samplers.
Então, o que eu entendi é que a técnica depende da situação. Então, se a situação tiver fundo móvel, é uma técnica, se não tiver fundo móvel, é outra técnica. A técnica está ligada à situação, ao evento.
Vamos fazer o seguinte, só por causa do horário, como a gente ainda tem quinta e sexta, a gente vai ter, sem querer parar a discussão, mas como o Mike ainda tem uma apresentação e depois ainda vou falar alguma coisa do campo, e a gente ainda tem mais 3 dias de workshop, a gente pode discutir isso mais ao longo da semana, né, se não for um problema. Mas essas perguntas foram interessantes. Mike, por favor. Obrigado, Tim.
Yeah, we'll discuss that more later. Oops. Still on.
Okay, let's talk about the fun stuff, safety. So, just so you know, I'm not a safety officer. I don't teach safety in my center, but I have been through 33 safety training sessions over the 33 years, and so I tried to compile a few things that we could show, and hopefully this will help keep you safe in the field. Maybe get you to think about a few things that you may want to do, or some documentation to plan with. And so this is going to be fairly quick, but I think it's very informative. So I always try to think about safety when they're in the field, because our center was told by our director years ago that he really stressed the point of safety in the field, because he looked at each and every one of us and he said, I don't want to have to be that person that has to make that phone call to your family. So please do everything that we ask you to do in the field. That none of what we do is that important. So just think about that when you're out in the field. We all know about life jackets. The USGS, we have a national policy with our agency that we are required to wear a field jacket if we are in, above, or on the water, regardless of the depth. It could be 6 inches, and we need to have life jackets on. That way there's no exceptions. There's no exceptions to the rule, and so if somebody said, well, I didn't know it was that deep, so that's what they require us to do. So we have these inflatable PFDs now that are out. They're much lightweight. They're cooler in the summer, but we have to do the maintenance on those, and they have to be inspected routinely to make sure that they're still able to work. How many folks have seen these type of life jackets where they have the CO2 cartridges and they inflate? Right. So the thing that you have to do with those is keep the maintenance up on them. I had one myself that I thought was fine. Went to do an inspection on it and blow it up. It would not hold air for more than 5 minutes. It had, the seam had a crack in the side of it. So there are several safety plans that the USGS requires our centers to do and follow up with and keep current in our safety operations. One of which is the job site hazard analysis, a JHA. It describes what's going on at the site, the type of hazards that are there, the things that someone could incur. I'll show you a copy of one of those. The sampling plans, bridge traffic plans is another big thing that we employ. Our boat float plans. Before a crew goes out onto the river, they have to submit a boat plan. Where they're launching from, who's with them, how long are they going to be gone, what sites they're going to, and what their contact information would be and what time to be expected back. They have an onshore person that they should contact when they get back. Also, fall protection plans and emergency contact information. Always there's proper clothes to wear in the field. We're dealing with things that can be caught and torn, the reels that we deal with and those type of things. Heavy clothes, gloves can protect your fingers. When you're working with heavier equipment, you want to be sure to wear steel-toed boots. Accidents happen. They happen quickly. So, of course, we covered the PFDs. This is an example of a JHA, a job hazard analysis that we use for every site that we have, that we operate continuously. It's a simple form, and you can basically put anything you want to in here, but what it does is it outlines what people that are going to that site need to look out for. They may not be aware. Maybe there's someone, maybe you're out sick and someone has to go to your site for you, and you're unaware that the rocks are loose at the section where you walk down to the stream. So it outlines all of this information, the access to the stream, where you can measure it, where the best place to measure it during floods. Here it's got when the stage is above 4.5 feet, measurements are made on the downstream side of the Valley Street Bridge. At medium stages and high stages, discharge measurements are made from the downstream side of the bridge. Basic stuff. Stream banks are covered with riprap. That's another word we use for large limestone blocks that are bank stabilization boulders. It's got emergency contact numbers, the nearest hospital. Venomous snakes are present around the gauge. So, you know, these type of things are just information to know. And so this is required. As far as weighting goes, I'm sure you all have weighted a stream at some time or another. Don't push that limit. Know when you can get out there and when you can't. You know, these bottoms are moving. This fellow here is really taking a risk out there today trying to get this measurement. There can be slick, rocky beds. At some point in time, you're going to not be able to stand up. Even if you've got a tag line or some type of rope tied across there, maybe it's just best to do it in a different method. You know, you don't want to be the only person out here and being swept downstream, and then we have other problems. And then there's quicksand. I've been trapped in some quicksand in South Mississippi. Sampling from bridges has its own hazards. We try to, if there is a walkway that's separated from the traffic, this is much nicer. Handrails are always nice to have. Cones out when you're working. I'll cover this a little bit more. Sometimes we've had to be out on bridges. We don't do this much anymore with trucks, with emergency lights going so that we're seen. You know, there's all types of hazards there that we may or may not see. You're working over water over a handrail for one reason. It could be fast, rapid floodwaters. We've got heavy counterweights here. We've got moving parts here that could get fingers. A curb you could trip on. And you've also got traffic coming. One thing that the USGS has really tried to promote is we want to be seen when we're out there. So we have the brightest clothes we can find. These are the standard types of clothing that we wear when we're out in the field. We have field shirts for all of our field personnel. They're free. They wear them. Our office buys them. We have long sleeve. They have reflective tape on them. They may not be the prettiest thing, but I guarantee you the cars will see you out there, and they will slow down. Even if they are, say, just doing some type of side work on the bridge, or they're out in the gauging area, and they don't have a shirt like that on, we have these slip-on vests that slip over, that are breathing. And so, you know, they're very visible, but the car coming around the corner that is sending a text to their friend, and they don't see you, this may be what you need. So, you know, these are the type of things that we use. And you can see these guys here going out to make a tether boat measurement. I don't think anybody could miss them. They're like glowing in the dark. So we want to be seen, and we want people to see, excuse me, see us. Traffic control plans are a major part of sites where we're required to get out on the bridge. There are all types of situations where there may be an emergency lane, there may not be an emergency lane where there's actually room to get out of the traffic. We may have to block traffic in certain situations. So there are all types of bridges, whether they're over a hill, there's poor visibility around a curve, there may be light traffic. It may be out in the countryside where there's only a couple cars every 30 minutes. There is a plan for each one of those situations. Each one of our field crews are required to establish which plan is to be used for which site on their trip. And they're reviewed on this. It has to be in that site folder, and it has to be available in the truck or in the gauging station. In case someone else comes, it's available. And the safety equipment, the cones that are used, are all available. And so the way we developed this years ago was we worked with our local state highway department. They have these plans already in place that work for them when they have to do repairs on the road, when they're doing road construction. And so we follow their lead in the plan that needs to be out, the number of cones, and it specifically is designed to show how many feet this sign's shoulder work ahead needs to be. This one is for shoulders greater than 30 minutes. This is a shoulder. There's room here for this truck to park, but he's going to be there for greater than 30 minutes doing some sort of work. This is shoulders less than 30 minutes. Can pull off to read the staff gauge very quickly and get back in the truck and leave, and there's nothing required. So these are the things that we use when we're in these type of situations. More dangerous situations where we're actually blocking traffic, we have to stop traffic in one lane to do work. There are 3 or 4 signs on either side. We've got flaggers that are stopping traffic. It depends on the amount of traffic we have, the visibility of the bridge. If it's in a curve and we have to, then we may have 3 or 4 people out stopping traffic. But we have training every year that we go through these policies and these situations so that everybody knows how to do their job if they're out helping. It may take 3 people to make the measurement, or even 4. Luckily, we don't have to get out on the bridge that much anymore with the use of tether boats. So these situations are limited because of the new technologies that we're using now with the ADCPs and the tether boats. But in cases that we are still out there pulling the boat, there's one man still pulling the tether across the bridge, we may have to implement some of this, you know. Then there's fall protection. Climbing up long, tall ladders on stilling wells, or doing gauge construction where you're having to go up to larger heights to install pipes or gauges. There are companies that sell fall protection harnesses, and the cords and the way that this works with the pulleys, you have a harness. If you were to fall, it's going to break your fall slowly. And so we have these type of gauges on the coast and other locations that we're required to wear these harnesses, and they're hooked on as the first person goes up, and then the second person can use the rope that's lowered down, and they would prevent a fall if something were to happen. It's not fun to probably put on or wear, but it could save your life. So, you know, you have to do these things. We have to do these things. It's required by us. So I wanted to share this with you so that you could maybe think about some of these things as well. Excuse me. Boat safety. Boat safety is, I talked a little bit about that in the large river sampling presentation. But boat safety is in a league of its own, if you will, because it's a different type of situation. You can't just walk away from the boat like you can on a bridge or somewhere else. So there are other things We have requirements for all of our boat operators that are drivers have to go to an MOCC course and become certified to drive boats. It's a fairly simple course, but it covers the basic operation and things that you should look for when you're out there driving this boat. It teaches a lot of people how to back trailers, launch a boat from a trailer that did not know how to do that, and so makes you more familiar of the workings of boats, and so that has to be refreshed, I believe, every 5 years. Float plans. Also very important. So recommended float plans that we follow, the things that we do, we have a description of the boat. We have a list of how many people are going, the point of departure, the planned route, those type of things. A lot of times these things are routine. And so really the only thing that needs to be changed is maybe the date and the number of people going and the location. So it makes it more simple. The means to contact the boat. Well, where'd I go? The purpose of the trip. The plan of action if overdue with a primary coordinator and contact person back at the office. You know, we didn't see Tim back. Molly and Tim were out on, you know, so-and-so river. They were supposed to be back at 4. It's 7:30. Has anybody called them? So it's that type of thing. There's one person that's looking for them to pull back into the office or at least give them a phone call or text when they're out on these larger rivers doing this type of work. So this is an example of one of our float plans. It's got the name of the boat, the list of the people working there, where they're launching, emergency equipment on board, you know, their planned route, estimated time of departure, the mean contact, the lead person on the boat, their phone number, excuse me, purpose of the trip, the description of the vehicle left at the ramp, and those types of things. Who to call. Boat operations. I'd already talked about the distribution of the weight with the samplers and things, so we'll just skip over that. Another thing that can kind of play into boat safety is the condition of your equipment. These frayed lines like this can become a problem. The pulleys on the E-reels, if the cable is not wound back on these reels properly, when you're taking bed material samples and this starts to move the cable over, eventually this cable's going to wrap around and it's going to be inoperable. And you've got a 200-pound sampler down how far? And you're off the back of a boat. It's dangerous. So this needs to be corrected. On boats in these situations, you can't walk away. So this is important stuff. This is a lady down in Baton Rouge, and she is she's holding on to this, which we don't recommend, but she's trying to keep tension on this cable while she winds it back up so it doesn't end up in the situation before. I talked to you about the float plans and things, and one of the other about not sampling for bed material off of the back of the boat. This was one of our boats that had to change locations because they weren't able to get any material at a local site on the Chaffalaya River. They had been sampling this site for 6-7 years, more. Very familiar with it. The lead person on this boat had done this thousands of times. They were in an eddy. The water was up a little bit. They wanted to move upstream about a couple hundred meters, maybe, within visible sight. So they did, and they were training some other folks on the boat, but they had been there several times. What happened was they were using a shipwreck bed material sampler. It is not streamlined. It has rods that stick out, and it's more for lakes or seabed type collection. They lowered that sampler, and the boat drifted a little bit, and it went down in what we call bank stabilization concrete mats. and was wedged in between those mats. Trying to bring that up, there was no way to get it out. Tried to release the cable. As the boat's turning around, the communications got mixed up, and so the boat came around. The main guy tried to reach out and cut the cable. As he reached out, he's putting more weight on the back of the boat. It started going more and more. He couldn't reach the cable. Water's coming in the boat. Before they knew it, it flipped over. Luckily, no one was hurt. They were able to get out. They had GPS personal spots with them. They had a float plan. Excuse me. They did float a couple of miles downstream before they were able to get over to the bank. But these things happen quickly, is what I'm trying to explain. These folks were probably one of the most experienced teams that we have. They were not out there blindly looking at it. Oh, thank you. Yeah, I've got some here. So, boat emergency procedures, the roles and responsibilities. We try to go over what-if scenarios and drill these situations. We don't spend a lot of time on it, but the crews themselves, they know what's going to go on if something happens. We know the people in our crew. I may ask you, if you're new, maybe a personal question, do you know how to swim? Because if you don't, then maybe we need to keep a special eye out for you. It doesn't matter if you don't know how to swim, but you may be a little bit more nervy, you know, if something were to happen and that type of thing, even though we all have life jackets on. So you need to know a lot of different things, maybe the health, if somebody is a diabetic on your team, you know, they could not have taken their medicine that morning. They're on the back of the boat. You turn around, they're gone. Well, they passed out and fell over. So those types of things. Things to consider, CPR and first aid, training, allergy medications, diabetics, those type of things. Personal health conditions of the crew members. Heavy lifting always with the equipment that we have to work with. Steel-toed boots, site conditions, weathers, flood, those type of things. We have each one of our centers and offices dedicate a week a year for safety training. It takes a lot of time out of our schedule, but we stop for a week a year, and we're either taking some online training, refresher courses. We're going into CPR, doing our CPR training. We have done this year, actually I don't have it listed, we had a wilderness first aid where we had some guys that came that were ex-Army Rangers that taught us, you know, these are the things that you have to do to survive to get out of the wilderness if you were to break your leg and you were with someone, or if this happens, or if that happens, or if you're bleeding profusely type of things. Really informative things to know. The traffic control plan, I've already talked about, the boat operation and the fall safety. This is a report that's been out for a good while. It talks about a lot of things as far as field safety, but it has some good information there that you may want to look at. And so hopefully that was quick enough. Wanted to cover all those, but just some things to keep in mind. And so sometimes people, you know, they go, Mike gets a little on edge out in the field sometimes. He's a little too particular about things. Well, sometimes you have to be. You know, I don't want to see anybody get hurt. You know, as long as we're able to do our job and do it safely, that's the important thing. You know, a lot of times we tend to skip over the safety part of it, but it can be fun, but we can be safe at the same time. Questions? Help me out, Tim. Pulmonary CPR, resuscitation. Yeah, thank you, thank you. I've had it long enough, I should have known the...
A minha pergunta é sobre os float plans. Esses são planos que vocês fazem, é só internamente que vocês lidam com eles, ou é um plano que vocês precisam fazer para a autoridade marítima, para alguma outra entidade federal?
The float plans, yes. So the float plans we only do for our USGS work. Even if we're doing it for a cooperator or whatever it may be, if we're using our USGS equipment, our USGS folks, then yes, we have a float plan for that particular work. Does that answer your question?
Eu gostaria de esclarecer 2 pontos. Na sua apresentação, você falou quando a equipe está fazendo o trabalho em pontes, que tem o controle de tráfego. O controle de tráfego é responsabilidade do SGS, da equipe do SGS, ou eles solicitam o apoio do escritório local, que é responsável pela rodovia, para que ele ajude o SGS na execução do trabalho?
No, it is solely our responsibility. We do not use the other state entities to support us in that matter. They will not do that. They will not come out and set up and close the road. So it's solely on our responsibility. We buy the equipment. We are trained. Our traffic plan is signed by the state, and so it's solely our responsibility.
O segundo ponto, só Roberto. O segundo ponto seria com relação ao que você falou a respeito do uso do EPI. Dentro do SGS, existe alguma penalidade para o colaborador que não use o EPI durante a atividade de campo?
Using the PDFs, the float jackets, is that? Any equipment? Yes. And I'll expand on that a little bit. Policies may vary from center to center somewhat, but in our center, in the LMG center that I am from, I can only speak from there. I'm not familiar with the other policies, but I believe they are very similar. The policy that was last enforced and still is enforced, I believe. If you are caught in a river without your life jacket, then you will go home for 3 or 4 days, and your supervisor will go home for 3 or 4 days. So not only does it tackle you, it tackles your supervisor. So then you have 2 that are looking at it. So that's kind of a double. You know, I mean, right. You know. The other thing that I think really is bringing our folks in, and they have really done well wearing PFDs, the life vests and things in the river. They have seen examples on social media of maybe a person here and there in the background. Someone's taking a picture for Facebook, and it's got USGS, and then you see that person in the background, and they don't have a life jacket on. And they get made an example of, and it gets out to others, and they don't want to be that person. So it's not maybe just that they're trying to be safe, they don't want to be that, but it's making them safe. When today's day and time with all of the social media, you're being seen, you know, so that's, you know, and that's a good thing. So anyway. We haven't had, I don't think, anyone go home on that situation, but that was what was put out to us as policy. So doesn't matter if the water's this deep or if it's this deep. You wear your life jacket if you're on top of the bridge, if you're in, above, or near the water. You know, have it hooked on your arm, have it on. So that's the way it works. Questions? Any more questions? Yes, sir.
A minha pergunta é a seguinte: a gente está aqui estudando sobre sedimentos, né? A maioria de nós está indo para campo para trabalhar com hidrologia. E tem muitos detalhes, muitas tecnologias novas, a gente tem que estar atento a isso e o nosso foco é isso. Então, a gente não tem um olhar treinado para o risco. Então, eu queria saber, dentro dessas recomendações que vocês têm, qual é o apoio que vocês têm no sentido se há um departamento, um profissional no SGS ou uma consultoria que vocês contratem para avaliar os riscos das atividades. Eu vi, por exemplo, nessa plataforma, a foto que você colocou, a mulher estava com a segurança, mas ela estava com roupas leves, de short e tal, que eu acho que em algumas situações aqui o pessoal ia achar estranho isso, porque acha que a roupa também seria um EPI e tal, e às vezes a gente está com um EPI excessivo, com esse equipamento de proteção excessivo para a necessidade, ou às vezes está ou tá menos, e a gente não tem... O nosso foco está na hidrologia. Então, às vezes, a gente acha que está seguro, mas a gente não tem esse olhar treinado para o risco. Então, eu queria saber como que é esse processo de elaborar os procedimentos, as recomendações, né, as políticas, né, de punição, né, caso não use. Como é essa assessoria de vocês?
We have not hired an outside person to come in and train us with this. Over the years, the USGS have had national safety officers that have been to school and they have studied under others. And so we've kind of formulated that pyramid, if you would. We have regional safety officers. We have someone in each office that is responsible for the things that we do for our safety. It's a side job. It's probably 10% of their job to do the safety, order the life jackets, order these type of jackets, chemical hygiene, how we get rid of some of our chemicals, and those type of things. But it's been a long process. But no, we don't have an external review. We don't have our national OSHA come in and review us, although we do have strict reviews from outside our office. Other USGS offices come to look because we're much broader, and so there's those folks that we have that some of them are strictly safety, but there's only a few national folks that are only safety. But so you have to start somewhere. So from the ground up, and then it would grow. You know, starting with these plans, these safety plans, and thinking about it, and the more you think about it, then the more it starts to grow, and the documentation starts to be there. And so, you know.
Mike.
Só complementando, porque a minha impressão é exatamente essa. Foi criada uma cultura de segurança e existem algumas situações que são repetitivas. Então, se eu já identifiquei o risco, eu não preciso realmente estar todo ano, todo momento, tendo que avaliar o risco. Então, eu imagino que esse conhecimento vai se construindo e se acumulando. Mas, assim, pelo que você falou, houve um processo de pesquisa e de avaliação de pessoas que olharam para esse risco, né, que tinham esse olhar treinado. Né?
We had a tragedy in Mississippi back in the 70s that before I started, we had a man, his name was Tommy Anderson. Tommy was on a bridge by himself making a bridge measurement with a truck in South Mississippi. He had finished the measurement. He was leaning over to read the outside gauge, had the truck here. An intoxicated driver came around the curve and hit the truck, and he went over. Found him, the folks at that time found him several miles downstream, and he lost his life making a discharge measurement. So I think after that time, our center became more focused on bird safety. I don't know if it's our office in particular. The USGS in a whole has always had a big advocate of our safety, but we're better. We're better. We keep getting better, and we keep growing, and that's the way. But sadly enough, we have had a couple of fatalities nationwide, but not many. And that's, you know, thank goodness. Thank you.
Pessoal, chegando na última apresentação, agora pela programação a gente vai falar um pouco sobre a saída de campo amanhã, né? Primeira questão do horário, a gente vai sair. A Diana, se eu falar alguma coisa errada, você me corrige, viu? Que a Diana foi que preparou tudo. Amanhã a gente vai sair de 8 horas daqui, junto ali entre o bloco L e o bloco M, né? Serão algumas vans para todo mundo. O horário é importante, vai sair às 8, né? Então todo mundo tem que ir, é bom chegar antes para não correr o risco de pegar algum trânsito e ficar, né? Tendo em vista que o lugar é longe, são longe entre aspas, né? 100 quilômetros daqui. Quando a gente vai de van, 1h30, 1h40, a gente vai estar lá. O pessoal que vai dar apoio de campo, é lógico que muita gente aqui é de campo, né? Mas quem tem a estrutura com os equipamentos vai ser o pessoal da CPRM Goiânia, que já vai amanhã logo cedo para lá. Eu acho que não estão mais nem aqui, né? Já devem estar se organizando. Ah, não, tem 2 ali, pronto. Vão sair as duas equipes para lá logo cedo. Como a gente sai daqui 8 horas, vai chegar lá umas 9h30, 9h40. Então, no máximo 10 horas, as medições de vazão já estarão prontas. Tanto a medição acústica, né, como a medição com molinete, para a gente ter as profundidades, velocidades certinhas. Vamos passar 2 sessões com cabo de aço. São 3 barcos, a gente já fez vários cursos lá, vai ser bem tranquilo, né? Aí a ideia é que a gente aqui, né, mostre como a gente faz a amostragem, como é rápido, teoricamente, né, pulando algumas etapas, né? Eu já estou até com as fichas aqui, tanto as nossas, que a gente usa quando precisa, né, no que pesa que a gente usa mais o sedimentos, como do SGS. As nossas, eu já estava olhando aqui a ficha, a gente já vai pular esse cabeçalho todo, né? Vamos ao que interessa, né? Logo, que a ideia é passar exatamente como a gente faz aqui no Brasil. Depois o Alvo vai mostrar como é que faz no sedimentos. Então, a ideia é que a gente colete pelo menos uma vez, sei lá, em 10 verticais mesmo, metro igual a incremento de largura. A USGS mostra como é que eles fazem pelo metro igual a incremento de largura, né, com o número de verticais que eles normalmente utilizam. E a gente tem tempo também para aplicar o metro igual a incremento de descarga, que é normalmente que a gente faz isso, né, pelo menos nos cursos, na parte prática. Aplica o metro igual a incremento de largura, o metro igual a incremento de descarga, chegarão mais amostras lá para a máquina analisar, né, depois a gente manda para todo mundo. Então, serão aí 4, né, compostas, ou não, né? A outra a gente vai fazer separada, né? Então, seria, enfim, a gente vê o número de amostras amanhã, seria isso. Então, 8 horas, no máximo, todo mundo aqui, além do bloco L, bloco M, vai sair 8 horas, cheguem antes. Eu só vou mostrar aqui rapidinho, só o local, onde é o local, a maioria de vocês conhecem, Ah, sim, o período já está com fome, está falando de comida, mas é importante que eu ia esquecer. Pessoal, a gente tentou fazer uma coisa diferente para ter almoço, mas teve uma restrição aí, mas ninguém aqui tem problema. Quem tiver algum que precisa comer, já leva, passa no supermercado onde vocês estão, compra maçã, sei lá, algum biscoito, alguma coisa. A água, Diana, a gente está levando ou cada um tem que levar? Por segurança, cada um já leva a sua, né? Se tiver lá, já... Né?
A gente está levando um pouco de água, mas é importante que cada um leve o seu, porque está muito seco. A água que a gente está levando não vai dar para todo mundo.
Lá, água e comida. A gente só vai fornecer os amostradores. Não precisa...
Lá, só
então,
só para dar só mais uma informação. Lá perto, algumas pessoas conhecem, lá perto tem um mercadinho, para quem não não leva lanche e tal, mas quem tiver, é bom levar já.
Já
de
leva
casa,
daqui. Mas lá tem também, né? Quem porventura tem alguma dificuldade de comprar aqui, lá tem um mercadinho a 300 metros da estação. Eu só vou mostrar aqui rapidamente. A gente fecha aqui mais 5 minutinhos. Antes disso, como eu falei, não é insistir não a quem não possa, porque algumas pessoas não estavam aqui. Parte do pessoal aqui vai aqui para o restaurante Pinguim, aqui no Parque Shopping, que é pertinho daqui, logo quando sair daqui, né? Lá tem um happy hour até as 20 horas, que paga um valor fixo. Enfim, quem quiser ir, vai com o pessoal. Deixa eu só mostrar aqui a estação. A maioria de vocês conhece, né? Levanta a mão só para eu ver aqui, que eu já mandei as fotos lá para o pessoal do SGS, que aqui vários já fizeram vários cursos aqui na ANA, e a gente sempre vai para essa mesma estação, que é uma estação boa para curso. Levanta a mão quem nunca foi para essa estação no Rio São Bartolomeu. Foi muita gente, então vamos ter que...
Gente, só para dar mais... na verdade, eu ia pedir um favor para o Álvaro. Para quem não tiver o hidrossedimentos, disponibilizar no FTP, naquele FTP que a gente passou, para quem tiver com o notebook, quiser usar lá em campo, para poder usar.
Mas já está lá no FTP, Diana. Já está lá no FTP, nessa pasta aqui, ó. Essa que está projetada. Aí tem um arquivo compactado que tem assim, ANA Oficina Material. Aí lá tem vários materiais que normalmente a gente disponibiliza no curso, inclusive hidrossedimentos. Esse FTP foi encaminhado para todo mundo, né? Então a estação, pessoal, fica 100 quilômetros aqui da ANA, né? É nesse rio aqui, São Bartolomeu. Tem essa ponte aqui, né, mas a gente não usa, né? É exatamente nesse local aqui ó, que a gente fica. Né? A seção de réguas é um pouco aqui a jusante, a seção de medição é um pouco a montante. Né? Deixa eu só pegar aqui o dado. Então, essa é uma estação... Quem tem um aplicativo da gente, o Hidroeb, já pode consultar o dado. A estação é a 6050, o código dela. 6050. Então, no hidrotelemetria, então 6050, essa é uma estação que não é da nossa responsabilidade, é de responsabilidade da empresa do setor elétrico, mas ela é obrigada a enviar os dados aqui para a ANA. Essa aqui, o HE, mudou o nome dela nos últimos anos aí. O HE Batalha Rio São Bartolomeu. Vamos dar só uma olhada aqui nos dados dela. Vai estar muito baixo amanhã. Tem esse gráfico do último ano. Né, você vê que chuva, o último dia que teve chuva lá foi em... Tem muito tempo, hein? Foi em maio. Então, foi em maio, já temos aí o quê? 4 meses sem chuva registrada nessa estação. Né, o nível está bem baixo. Só colocar aqui a vazão. E a vazão vai estar baixa também. Né? Está no período seco aqui em Brasília. Só para fechar aqui, nós temos... Vai ser abaixo de 20, com certeza. Nós temos... eu tenho aqui, não. Nessa não tenho. Não, enfim. A gente tinha uma... umas fotos, mas está em outro local, não está aqui. Só um momentinho. Não sei se o... Aí sim, a ideia é o quê, pessoal? A gente vai levar vários amostradores. A gente não vai usar o DH48 provavelmente amanhã. Vamos usar o DH59 ou o D49. Provavelmente a gente vai levar o D96, só para ficar na margem ali, a gente explicar alguma coisa, discutir alguma coisa. A gente vai fazer a seleção lá do amostrador, do bico, né, de maneira... A gente está levando ficha para todo mundo e levando prancheta para alguns. Enfim, quem tiver prancheta, é bom levar, que não tem o suficiente para todos, não. Só mais 3 minutinhos, deixa eu ver se eu só consigo aqui acessar. Enquanto eu olho aqui, alguém tem alguma dúvida? Então deixa depois eu mostro isso aqui. Eu mostro... na quinta vai ter à tarde, aqui na estação, aqui próximo, 10 quilômetros daqui. Então, quinta de manhã a gente vem para cá para discutir algumas coisas, tem algumas apresentações, tem a apresentação da Magna, do Dalto e algumas do SGS. E na quinta tarde vai ser na estação aqui para fazer medição aval. É bem pertinho aqui da Ana. Ok? Enfim, eu não tenho as fotos dela aqui, está no meu computador, não vou, só para a gente não precisar ficar mais tempo. Não sei se o pessoal do SGS tem alguma coisa adicional, alguma dúvida. Não? Alguém tem mais algum questionamento? Não? Então amanhã, pessoal, lembrando o horário, viu? Amanhã, no máximo, 8 horas aqui no bloco L, que é onde vai sair, não é aqui nessa entrada, não, na saída de lá. 8 horas no máximo está saindo todos os carros para o local da Alicampo. Até amanhã. Boa noite.